توفيق افضل الانبياء والمرسلين نبينا محمد وعلى اله وصحبه اجمعين. جلستنا اليوم هي جلسه التحليه الخيار الاستراتيجي من دول مجلس التعاون. في هذه الجلسه بتشارك المهندس علي رضا وانا احمد العربي في اداره هذه الجلسه. بسم الله الرحمن الرحيم.
السلام عليكم ورحمه الله وبركاته. I'll switch to English, please, because our first speaker, our keynote speaker, is Dr. Son. Dr. Son will speak about the hybrid desalination technologies for sustainable water energy nexus. Innovation and integrated membrane development. Dr. Son works for he's the Associate Professor of Civil and Environmental Engineering Program of Prince Sultan University in Riyadh. We'll not go through the details of his career. He is well known, and I'll give you the floor, Dr. Son, to start so we can finish as quick as possible.
Thank you very much for the kind introduction. Good morning, all the gentlemen. This is Hyuk-soo Son from the Prince Sultan University, and I was affiliated with Water Research Desalination and Reuse Center in King Abdullah University Science and Technology House before. And first of all, I'd like to thank you very much for the Ministry of Water, Environment, Water, Agriculture, and Water Science and Technology Association, and the General Secretary of Gulf Cooperation Council for organizing this wonderful event, meaningful at this time and era. And this morning, I'd like to briefly introduce about hybrid desalination technology for sustainable water energy nexus, innovation in integrated membrane module development. My presentation will follow the order of introduction, hybrid desalination, and the FOMD hybrid system as a case study, including the methodology and the research. And it will follow the conclusion and the recommendations and create acknowledgements. Yesterday, we already discussed a lot about the importance of the water scarcity, and it's mainly because of the climate change and the environmental pollution and the population growth. To overcome this imminent challenge of the water resource, desalination became inevitable option. Over the last 30 years, trend of the annual capacity has been increased, and it is expected to reach 250 million cubic meter per day in the 2030. Although it was stalled a bit during the around 2015, it has been gradually increased. And we see the recent data, most of the water resource, the water sources coming for the desalination is 61% of the seawater and 21% for the brackish water. This table and the map are showing the global distribution of operation desalination facilities and the capacities. Desalination is in the Middle East, and the North Africa region covers almost half of the global total capacity. Despite of the significant growth of the desalination, still there is a concern about the sustainability, because from using the seawater with the energy and the chemicals, we produce the fresh water, but at the same time, greenhouse gases and the brine is released. The main challenge of the desalination technology lies in the reducing the energy consumption and the minimizing the brine disposals. And also we can see the energy consumption of the desalination is closely related to the economic sustainability as well. Thus tackling these problems of energy requirements are the key to the sustainable development. Various approaches are applied to overcome the current challenges in the desalination by developing new desalination technologies, novel material, and advanced process design. Among existing solutions, hybrid desalination technologies are one of the promising options. And according to the reference, the hybrid desalination is a technology with both high sustainability and the technology readiness level. Mainly, it is because of the hybridization can maximize advantage and minimizing the drawback of the multiple processes. The number of annual research publication under the keyword the hybrid desalination has been consistently increased from the 13 in the 2005 to over 300 in the 2020. Hybrid desalination technologies are already implemented in the industry widely, and also the promising possibilities are demonstrated in the literature. As a case study of hybrid desalination in the aspect of water energy nexus and the membrane module design, I'd like to present about the recent ongoing project on FOMD hybrid desalination. This project is a collaboration project between the Saudi Aramco and the KAUST. The objective is to investigate the feasibility and the performance of the novel integrated membrane system for the simultaneous treatment of produced water in different impaired water quality. Produced water is a wastewater generated and considered as largest sporidium waste stream in oil and gas production. Unfortunately, produced water is considered as one of the most challenging water stream to be treated. It is because of complex mixture of dissolved and particulate, organic and inorganic chemicals in the wide range from the fresh water to concentrated saline brine as well. For sustainable water cycle in oil processing facility, we are looking for technologies are minimize water loss and maximize the water quality, and ultimately we can have the better efficiency of the oil processing process can be achieved. Many different technologies are under research for produced water treatment. I'd like to present our work with the poured osmosis and membrane distillation hybrid system today. As all of you know, the membrane, the process is a separation process using semi-permeable material, and different driving forces are used in various technologies. FO and MD, the technology introduced in this study is utilizing osmotic pressure and the vapor pressure as a driving force to transport water across membrane. In case of forward osmosis, since the driving force is osmotic pressure, FO is a technology, no need the pressure like RO with a high rejection, but requires regeneration of the draw solution. On the other hand, membrane distillation, MD, is a thermal membrane process that is driven by the difference in temperature, namely vapor pressure. MD has a strong advantage with a highly saline water, but has weakness with the volatile contaminants. In summary, FO driven by the osmotic pressure and the MD driven by the vapor pressure. What if we have the water solution or the stream has both high potential of osmotic pressure and the high temperature? If we just use the FO or MD, we are not utilizing all the energy we can extract from the water stream. So by only the single process, we cannot achieve the sustainable process. By hybridization, the system can use both energy potentials osmotic pressures and the vapor high temperature, both of them, and to maximize the system performance. As an example, one literature reported stable operation of the FOMD hybrid system is higher permeate quality. It highlights the benefit of the FOMD hybrid, not only a concept of the maximizing the energy use, but also at the same time, the drawback of the both process can be mitigated with the utilizing advantages of both processes. However, the design of these hybrid system can be complex and massive due to the inclusion of the multiple processes. Because of that reason, integrated module has been suggested to simplify combined membrane processes. But there are limited studies in the literature on integrated FOMD hybrid modules. In addition, even the literature report that the integrated module had less water production despite lower energy consumption and improved water quality. This drawback shows significant importance of innovation in conventional hybrid module design. Therefore, the integrated FOMD module with the osmotic and the thermal isolation barrier is developed and the patent by Professor Gafour and this group, where I was working in the CAUS to gain the maximum benefit of FOMD hybrid system. The isolation barrier allows thermal energy as using in MD, and osmotic pressure is FO processes efficiently. With the promising potential, we initiated the collaboration project, and this project is a design in 4 phases. First, feed water selection and characterization, and the lab scale experiment using synthetic feeds. For the second phase, we executed the lab scale experiments using synthetic and the real feed. And in the third, we did an experiment and for the feasibility and performance evaluation of the large scale hybrid MD module. Fourth, like we executed, we are ongoing on the research for the pre-treatment requirement, estimation of energy consumption analysis as well. Under the first phase, from the gas oil separation plant, we identified the water stream which we'll use in the FO and MD membrane hybrid system. We received 5 different water samples, desalted effluent, and the water oil, the separation outlet, wash water, 3-phase separator effluent, and the water reverse osmosis result from the plant. By following the water quality from the real sample, we prepared the synthetic water samples and conducted lab scale forward osmosis and the membrane distillation experiments. These are only the typical experimental data showing FOMD water production and the membrane surface analysis after the experiments. Definitely, fouling and the scaling are the main challenge of membrane processes, and the in-depth study has been conducted. Afterwards, the research on FOMD hybrid system by using integrated module is completed. Both conventional and the novel integrated module are designed and fabricated for the experimental study. We had a simulation data for this integrated module in previous study, but lab scale experiments by using synthetic and real produced water are conducted under this project. This is a typical process diagram for the lab scale FOMD hybrid experiments to evaluate the operation in real time. Conductivity and other data is collected with the data acquisition system. The experimental operations are conducted to investigate impact of the isolation barrier in different conditions such as hydrodynamic conditions and the feed solution concentration and draw solution temperatures and the draw solution concentration and etc. With the defined simulation models and experimental data, concentration and temperature polarization of the FO-MD hybrid system are analyzed. Polarization is one of the main challenges in membrane processes, which limiting the actual driving force from the work operation condition. Higher polarization coefficients implies lower polarization with a higher driving force at the same work operation conditions. With the novel design with the isolation barrier, concentration, polarization coefficients are increased for FO and MD. At the same time, temperature polarization of the MD is improved significantly, which demonstrates clear impact of isolation barrier in integrated FO-MD module. The contour graph is prepared to visualize osmotic and thermal impact of the novel design in the module with the barrier. The hot feed water is first entering to the MD side and maximizing the efficient use of thermal energy. And then by MD, the feed is concentrated to higher osmotic potential before entering to the FO process, which benefits the performance of the MD FO process. Energy efficiency is also improved by novel design with the isolation barrier. In the third phase of the project, feasibility of the performance evaluation is conducted for the large scale hybrid FO-MD module. And we can see that this result is showing that the comparison between the synthetic and the real stream, as you can see, there was some wetting happened in the after 60 hours, unfortunately. We conducted this research and using for the fourth phase, what kind of pretreatment and the cleaning method we have to use. So this is a still ongoing project, and you will see the result in the publication soon. So actually, I just discussed about this novel design of the isolation barrier. By the just only single a change, it improved a lot for this FO-MD hybrid system by maximizing energy potential, improving the system sustainability. In conclusion, hybrid desalination is one of the most practical and efficient technology can afford environmental and economic sustainability, and the membrane hybrid desalination system requires niche membrane module design depending on its technology and target water resources. As just a recommendation, we cannot just escape discussing about the renewable energy when we're talking about the hybrid desalination. So the desalination is actually I just only focus on the designing of the membrane module, but we can apply the same principle when we combine the different combination of the technologies. We have to understand the water quality of our target feed water, and also we have to understand the environmental requirements to use the proper technologies. There is no one best technologies, and we have to understand this unique purpose of the individual technologies. Actually, it is easy to say we have to do the customize the process every time for the individual process, but actually realistically it's not possible, because it needs a lot of effort to do the optimization of the processes. But now the emergence of artificial intelligence will help on this direction, optimizing, customizing our processes. Thank you for your kind attention, and I'd like to acknowledge King Abdullah University of the Science and Technology and the Professor Nordin Ghafor and the team and the Saudi Aramco and the Prince Sultan University. Thank you very much for your kind attention. Thank you.
Thank you very much. That was very interesting paper. We'll discuss it later when we go to the QA session. Thank you very much.
Thank you. Thank you very much.
Our second speaker is Dr. Hassan Abdurrahim. Could you please introduce yourself? Dr. Hassan.
Good morning, Dr. Hassan.
Good morning.
You are with us?
Yes, I'm waiting.
Okay, thank you very much. Well, thank you for being with us. We have a small problem of the techniques on the sound techniques. Well, we couldn't find your CV, Dr. Hassan. So if you please introduce quickly yourself and start with your lecture, please. Thank you for joining us again.
Thank you. Good morning. Why I cannot see my video? I cannot see my video. I cannot start my video here. I want to see the.
Doctor, can you ممكن تضغط الشير سكرين؟
Yes, أنا ضغطت الشير سكرين و I am sharing now my screen, but the video is not starting. When I try start video is not starting. It says you cannot start your video because the host has stopped it.
فيديو ما يقدر. فيديو ستوب. دكتور تفتح الفيديو من عندك؟ فاتح الفيديو؟
ايوه يا فندم، انا بضغط على ستارت فيديو بس هو زوم بيديني مسج you cannot start your video because the host has stopped it.
كيف ممكن؟ مفتوح عندنا دكتور، مفتوح الفيديو. على كل عندك البرزنتيشن دكتور؟
يعني حضرتك دلوقتي يعني okay, I will share screen again. Okay. Now can you see my screen?
Yes. Okay, you can start with your lecture, Doctor.
Okay, thank you. Assalamu alaikum. Good morning. This is Hassan Abdurrahim. I am associate research scientist at Kesar at Water Research Center, and I will present today the paper entitled Levelized Cost Analysis for Desalination Using Renewable Energy in GCC. The presentation have only 4 points. Desalination is the only source of fresh water in GCC except in Oman. Because of its lower energy use and water production cost, seawater reverse osmosis is the most common membrane desalination technology today. And even most Middle Eastern countries halted or significantly restricted the development of new thermal desalination plants after 2015. The online capacity worldwide shows that almost 80% of the desalination capacity is reverse osmosis. Also in the Middle East, it's about 50%, currently in 2021, and even the plant capacity until 2026 is almost all for reverse osmosis. And for this reason, this study is concentrated on reverse osmosis desalination plant. Desalination process is an energy intensive, where energy price representing more than 44% of the cost of the water. However, almost desalination plants, all desalination plants are using fossil fuel for securing the required energy, and it have great impact on the environment. GCC countries, however, are gifted with consistent and predictable solar energy that can be used to power the desalination process to improve their sustainability and to reduce the environmental impact. However, solar desalination is expected to become economically attractive, and the renewable technologies costs continue to decline, and the price of fossil fuel continue to increase. This paper, we studied the levelized cost of energy and the levelized cost of water for reference seawater reverse osmosis plant operated by solar energy, PV solar energy, in different countries within the GCC, in the 6 countries of the GCC. This paper proposed a platform using well-known and freely available software to estimate the levelized cost of water, of seawater reverse osmosis desalination plant operated by renewable energy power plant. The key factor for utilizing renewable energy in desalination is the overall cost of fresh water. The levelized cost of water represents the average cost for water production over the project life. It's the total value of energy cost of water produced divided by the total time. The energy cost is presented by the LCOE and is used in the calculation of the energy cost in water. In this work, a reference seawater reverse osmosis plant was selected for this investigation. The methodology in simple, the power needed for the seawater reverse osmosis was estimated using wave software by DuPont. Then the Desalination Economic Evaluation Program, DEEP, is used to calculate the levelized cost of water. After that, the System Advisor Model, SAM, from NREL, were used to evaluate the levelized cost of energy. However, the Power Purchase Agreement, PPA, obtained from SAM software is used to represent the levelized cost of energy. Levelized cost of energy from SAM is plugged into DEEP to evaluate the levelized cost of water. For the reference seawater reverse osmosis desalination plants, 400 meter cube per day, the required electric power is about 76 megawatt. So we designed a PV power plant of capacity 76 megawatt using SAM, and we obtained the levelized cost of energy. SAM used the DNI value from the weather data file. Each place, each location in the study we obtained the weather data, which include the DNI, the temperatures, the wind speed, and other data. So SAM uses DNI to evaluate and other parameters to evaluate the nominal capacity of the solar field. The financial model within SAM also taking into consideration the electricity purchase cost. And this is very important because this is the cost of the electricity taken from the grid to compensate for the night time, for the charging the battery, or for any other power required by the system at night, or when the system is not delivering power to the grid. So instead of cutting the operation, we use the grid power. The results, the seawater reverse osmosis plant is 2 pass using dual media filter, and the capacity is 400,000 meter cube per day. So the PV power plant, the designed power plant has 91 megawatts of DC capacity, which equivalent to 76 megawatts of AC power. Then we use the weather data for the 6 GCC countries. With the available data, which is like in Bahrain, the Bahrain International Airport, Kuwait International Airport, Muscat, Doha International, King Khalid International Airport, and in Abu Dhabi also the Abu Dhabi International Airport. And we obtained these data for the 6 PV power plant in the countries. However, the IRR, the return of the capital of the I mean the revenue of the plants is equal. We keep it equal, 13.07, and the cost, the PPA price, power purchase agreement price, the nominal price, which representing the current dollar value, costing around 9.8 cents in Bahrain and 9 and all these values. We use the PPA, not the LCOE, because we consider that the power will be purchased from the power plant. But if the plant is considered to be a completed project, including the desalination and the power generation, in that case, we can use only the levelized cost of energy. But because it's a separate project, we use the power purchase agreement. Then this value were taken to the other software, deep software, and we plugged these values to obtain the levelized cost of water in each country. And it, as we can see, there's no large difference between the cost. However, we will see in the conclusion, it's much lower than the conventional power plant. However, we studied more in Kuwait. We studied different locations in Kuwait, like the Kuwait International Airport and Failaka Island and Salmi, because these are studied areas for solar resources, and we found it promising. And again, we evaluated the power purchase agreement in these different locations. and then we estimated the cost of water, levelized cost of water in all these locations. In conclusion, like most power generation technologies, PV systems are capital intensive, but have no fuel cost. The levelized cost of energy for the studied locations ranged from 8.46 to 9.11 cent per kilowatt hour, and the levelized cost of water ranged from 103 to 105 cent per meter cube, compared to 10.74 cent per kilowatt hour and 110 cent per meter cube for the conventional combined cycle power plant. The three key drivers for the levelized cost of energy of PV power plants are the capital and the installation cost of the PV modules and the balance of system. The average annual electricity yield, kilowatt hour per kilowatt, functions of the local solar radiation and the solar cell technical performance, and the finance cost of the PV system. While desalination processes are still costly, declining renewable energy technology deployment costs are expected to bring the desalination cost down in the coming years. This is important to remote regions and islands with small populations and for areas of inadequate infrastructure for fresh water and electricity transmission and distribution. And thank you. I'm ready for any question.
Thank you. Thank you, Dr. Hassan, for your presentation. We will keep the question to the end of this session. We will move to the third session.
Thank you.
Ladies and gentlemen, we will leave the Q&A at the end of the session. And I would just like to remind each speaker, please, we need each of you to give us one recommendation for our recommendations, which we will be gathering later on. So we need one recommendation from each of you, if possible.
Also from the audience, please, anyone welcome any recommendation. So please, if you write across and to put it across, we will be thankful.
Okay, our next speaker is Mr. Engineer Ahmed Al-Zubari. Yeah. Ahmed, we welcome you to present your case. And if you just give a very short introduction to yourself.
Thank you.
And please, the floor is yours.
Okay. Thank you for the presentation. My name is Ahmed Al-Ghamdi. I have a master in water desalination with renewable energy. I am working in SWCC Research Center since 2010. Almost now 12 years working there. I am working mostly in thermal desalination and coupling the thermal desalination with the solar energy. First of all, I would like to thank you to give me this opportunity to talking about this research, which is a prospect of utilizing of solar energy in SWCC existed MED desalination satellite plants. The overview will be the introduction, objective and methodology, the result, affecting of performance ratio and the water cost, then conclusion and recommendation. With the increasing of water consumption and depleting of freshwater resource, there will be many areas we're facing the freshwater problem. Actually, Saudi Arabia and all Gulf countries is facing this challenge. As a nation of Saudi Arabia and Gulf countries, there is no the fresh water except underground water and desalination water. The seawater desalination is the most expensive way to produce the fresh water, especially at the commercial scale. This figure shows the breaking cost of water. Almost the fuel cost is taking a 50% of the break cost of water. So there are two ways to minimize the desalted water cost. One is reducing the fuel cost. Another one is to increasing the efficiency of the desalination system. This research is covered the 5 locations where there are existed MED TVC plant. It's a satellite small plant producing around 8,000 meter cube per day, starting with the north side, Al-Wajh, Amluj, then Rabigh, Al-Qunfada, and Farasan. Actually, this plant is typical design. So the design data is similar, but we use the actual operation data in this research. Also, this location have a high direct normal irradiation, starting in the north with the highest 2,500, and the southern one is Farasan is decreasing up to Farasan, which is in the south, with 1,500 kilowatt hour per meter square daily. So in this research, we will see also the effective of the direct normal irradiation and the water cost. The objective of this research is to make a techno-economic assessment by modeling the solar system with assisted MED TVC plant to evaluate the levelized cost of water with a different configuration and different storage, thermal storage. There are 2 configurations. The first one is a CSP assisted MED TVC without storage. And the second configuration is with 16-hour storage. The methodology is to using the direct normal irradiation, which is the actual data taken from the King Abdullah Center for the Atomic and Renewable Energy, and using the SAM advisor program. This used to calculate the area required for the solar system, and model the Excel program to coupling the solar field with the MED TVC to find out the breaking cost of water and to find out the levelized cost of water. So this is the first results. It shows the result for 0-hour storage without any storage, only using the CSP on the daytime and the fossil fuel in the night time. The figure here, it shows the dotted line is conventional MED. It's existed on the Al-Qunfada plant. And the other lines, it shows when you use the CSP for 0-hour storage. And we can see the breaking cost and feasibility for all the plants. When you couple it with the CSP, it's around $25 per barrel. So if the fuel cost is higher than $25 per barrel, this means this system is feasible. Except the Farasan plant, where the feasibility is starting from $48 per barrel because of the low DNI in the Farasan location. In this table, it shows the results, and also the important results here is the solar field area, which is very high. It's around 50,000 meters square for using the CSP with no storage. This result, it shows the CSP with the 16-hour storage, so it's fully working with the CSP without any fossil fuel. we can see the stability of the price of water from $10 to $100 per barrel. And the dotted line also, it shows the conventional MED TVC. And the breaking cost is increasing from 25 for 0-hour storage to 32 for 16-hour storage. But the area required is very huge. It's around 160,000 meters square. Then we made a same model, but with different performance ratio to see the effective of the performance ratio in the water cost. So the performance ratio in the existing plant now is 8.4, and we increase it to 12, 16, 20, then 24. So the cost is decreasing from $3 per meter cube to 1.2 meter per cube. The conclusion is the main issue in this plant is the energy cost, is energy consumption. Actually, it's very high. It's around 14.3 kilowatt hour per meter cube. Now, after this study, we can say that using a linear Fresnel with MED TVC is feasible when the fuel cost is higher than $25 per barrel. Performance ratio mainly affecting on the water cost when the MED coupled with the CSP. The cost of water higher in the case of 16-hour storage. However, it is the best choice when fuel cost is higher than a $50 per barrel, which is now is around $95 per barrel. Actually, we calculate the total saving if we couple this CSP with the existing plant. So the total saving will be around $21 million per year if we coupling this existing plant with a CSP. Also, the results showing the reducing of the carbon dioxide emission with around 420,000 tons per year for all selected plant if we couple it with a CSP. So the recommendation here is it's feasible for coupling the CSP with this satellite plant. However, is build the high performance MED TVC coupled with the CSP plant will be the best choice for affecting positively in the water cost. Also, the decision of the using the storage size is depend of the oil price, should be depend of the oil price. And we can see here in the around the average 5 years, the price of oil is higher than $50 per barrel. Thank you.
Thank you, Ahmed. Thank you very much. The fourth speaker, Professor Kim Sean, I think he will be online. Just he joined the water desalination center house in 2015. He worked in thermal-driven desalination process and energy efficiency improvement. He has over 300 publications and an index of 67 over 1,400 PhD. So then, answer please.
Presentation.
Hello.
Hello, Professor Kim.
Yes, yes. Somehow my screen is stuck. My screen is not. Yes, this is the correct screen here. Can you see my screen? Can you see my screen now?
Yes, yes, yes.
Okay, shall I start now?
Yeah, please, go ahead.
Okay. Good morning, everybody. My name is Kim Chun. I'm from KAUST. The topic that I'm presenting today is a common energy platform for evaluating the energy efficiency of power plants and desalination plants. The screen is stuck. It says cannot share screen.
You cannot share?
Yes, it cannot move. The video cannot move.
Is it your screen, doctor?
What is it?
Maybe I lock out and lock in again. Or someone can, from your side, can start the screen for me.
Presentation.
I'm showing presentation. Show them.
Maybe I lock out. Okay. Okay, let's start with it seems that I cannot have control over my screen.
No, we will move the
Okay.
by the
All right, it's okay to stay in this page. It's okay. Okay, this morning, the motivation for presenting this topic is to explain the misconception that existed in the desalination industry for decades. That is, 1 kilowatt-hour electric is not equal to 1 kilowatt thermal. This long-held misconception has unfortunately plagued the industry for a very long time. Now, to do this approach, we can use science, let's say using thermodynamics, and explain why 1 kilowatt-hour electricity is not equal to 1 kilowatt thermal. Here, I use a classical heat engines, as you can see a figure on the left, where the heat engines are drawing heat at a high temperature of 1750 Kelvin on the left. In the middle heat engine, it draws at 100 Kelvin, while the heat engine on the right is drawing heat from the high temperature reservoir at 350 Kelvin. And all these heat engines are rejecting into the ambient, about 30 degrees Celsius, for example. So, and the heat drawn from these reservoirs are all the same. 1 kilowatt-hour, which is about 3.6 megajoules. So you can see that the corresponding Carnot work from this engine, from basic heat engine thermodynamics, is 0.8268 kilowatt-hour for the engine on the right, on the left, and then in the middle is about 0.697, and on the right-hand side, where the heat source temperature is low, is only 0.134. Now, if you were to see the table on the left, all the QH is the same, 1 kilowatt-hour, but the work output, which is representing the quality of the energy, is decreasing from 82% of one, 69% of in the middle case, to 13% in the last case. Can you move the figure up a little bit? Oh, sorry. So go back to the previous figure. It seems that so based on this, go back to the previous figure. Previous figure. Slide number 2. Up again. So here you can see that this essentially heat transfer is insensitive to the quality of the energy that is coming from the heat engine. The only energy that is sensitive, unique, is what we call the standard primary energy, which is QSPE. And you can see that for this case, at 1750 Kelvin, which is the adiabatic flame temperature of the fuel that's consumed by the heat engine, the QSP is the same as a Q heat transfer. But as the work quality reduces, the QSP also correspondingly uniquely reduced, as you can see, from 834 to 0.162. So therefore, in order to compare apple with apple of different engines producing different work, we cannot rely on conventional heat transfer. You have to have a common platform so that you can define the energy quality. Next slide, please. Now, this shows the typical derived energy generation in the typical plant called the combined gas turbine plant. And this is normally co-located with all desalination plants, large-scale desalination plants. Next slide, please. So until today, all energy efficiency was evaluating from derived energy, which is in brown in the figure on the left, whether it's electricity or heat, to the useful product on the right side, the green. That is water. But that way of defining efficiency will be causing some misconception, because this way of quantifying energy doesn't tell the quality of the energy. So what we need to do is to present the efficiency right from the primary energy on the left in pink, right to the useful product. And here, the classical heat engines can be used to explain how to transform this derived energy explained in the yellow back to the standard primary energy, which is in the pink. And the picture on the right shows the what they call decomposition of this heat transfer from conventional heat transfer to the primary standard primary energy on the right. Next slide, please. So here is some basic equations that you can see tells how the classical laws of thermodynamics can explain the quantitative and qualitative aspect of the energy. We can see that for any heat engine, the Carnot work is a function of the heat transfer times the temperature ratio, 1 minus TL over TH. And so we need to convert this ideal engine into the real case in a real plant, and we use a second law efficiency shown in the bracket on the middle, where the Carnot work can be converted into actual work over the second law efficiency of the plant. If it's an electricity generation plant, it will be the second law efficiency, eta to the prime, double prime, as shown in the middle. So therefore, we can come up with a basic relations to convert actual electricity back to standard primary energy on the right-hand side, if you know the design temperature, if you know the second law efficiency of the particular process. Next slide, please. And the same can also be done on the heat transfer. So to do this, we access the basic data of a common CCGT plant. The y-axis represents the standard primary energy that is delivered to the plant, to the gas turbine. And from the gas turbine, the exhaust of the gas turbine is then recovered to generate steam to run the steam turbine, and finally extracting the steam at low temperature to run the MED. The blue lines represents the standard primary energy is in the whole plant. In this case, the total value is 2000 megawatt. And you can see that the electricity production given in brown bars of the gas turbine is typically shown reducing with the steam turbine reducing to about 300 something. And when you compare all this at a common platform, you find that the conversion factor to produce 1 kilowatt hour of electricity would require 1.7328 kilowatt hour of primary energy, standard primary energy. On the other hand, at low temperature, the thermal heat that we draw at 75 or 65 degrees Celsius is only 0.189 of the standard primary energy. So in other words, if you take the ratio of electricity to thermal, you can see that the electricity actually demands 16 times more standard primary energy that you burn in the power plant to produce than the 1 kilowatt hour of the thermal that you measure. Therefore, in other words, they are exactly not the same. In fact, the thermal temperature heat source that you draw at low temperature is 1/16 times that of the electricity. Next slide, please. So we go back to the literature. We examine more than 60 plants of all methods, practical methods of desalination. You see, and then compare these performances against the thermodynamic limit. As you know, thermodynamic limit, which is based on Gibbs function, tells the minimum work that is needed to separate the salts. And this minimum work is about 0.78 kilowatt-hour work per meter cube of water. And we will convert to the standard primary energy platform, that becomes about 0.943 kilowatt-hour of standard primary energy at the thermodynamic limit per meter cube of water. And we compare all that data for the SWRO, MED, and NOSF, you see that they range from 5 to 8 times more than the thermodynamic limit. And in fact, they are all about the same. They are all 5 to 8 times more than what is theoretically needed under the ideal condition of thermodynamic limit. Therefore, in order to reduce this standard primary energy consumption, you need to devise better processes that is more synergistic. And one approach is hybridization, as mentioned by many speakers earlier. And this way, you can then compare the efficiency of desalination processes on a common energy platform. This idea is very simple, it's motivated by science, it's not technology-based, and therefore, all the professionals in desalination should then use science to guide them how to compare one specific energy consumption of one type of process to another using the common platform. Next, please.
So can we have 2 minutes, please? Okay.
Yeah, this is a conclusion. So in other words, you need to really consider the quality of the energy, not just the quantity, in order to be able to compare apple with apple, whether it's electrically driven or the thermally driven plants. And unfortunately, this misconception has been long held, more than 70 years. And today we have resolved this misconception using science, using thermodynamics. And the best practical desalination plant available today is greater than 5 kilowatt-hour standard primary energy. Note the standard primary energy, not the derived energy that you measure, because that gives you only the quantitative value, but not the quality of the energy. Standard primary energy is the energy that is available to you, like natural gas or coal or whatever that's available to you. And the target that we want to go against is the thermodynamic limit. We try to approach the minimum energy by ideal situation that will be about 1.95 kilowatt-hour standard primary energy. So we can achieve this to better thermodynamic. We have to work harder to improve the processes to better thermodynamic synergy among different processes, whether it's work-driven or thermally driven. So with this note, I thank you for listening.
Thank you, Professor. The question and answer will be at the end of this session.
Well, ladies and gentlemen, our next speaker and last speaker in this session would be Dr. Riyadh. Dr. Riyadh is here with us. Dr. Riyadh is an associate professor in Riyadh University. He had his BSc and master degree in civil engineering, and he got his PhD in environmental engineering, desalination, water desalination. As a presentation, Dr. Riyadh, it's very long title, Dr. Riyadh. It's very long title, sorry. I will leave it to you, but I think you are going to talk about the green approach, right?
Yeah.
The green approach
To, I want to talk about one experiment.
Yeah.
One technology experiment.
Zero.
Yes, yes. Thank you, Dr. Ahmed, and thank you, Mr. Ali, for this introduction. My name is Riyadh, Assistant Professor in Al-Jawf, University. Today, I will talk about one technology. and called is direct contact spray evaporation and condensation desalination. And I will use the one method or something called micro nano bubbles assistant to direct contact spray evaporation. We know all the traditional technology, such as thermal or membrane, such as IND and NSF, or RO, it has some problems such as fouling, high capital cost, maintenance, and the Gulf Sea or Gulf Arabian Sea, it has yes. Okay. And the Gulf Arabian, it has ultra bombs and make a lot of problem for membrane or for MED and MSF. Because for membrane fouling and for MSF and MED scaling or corrosion. And this idea for this project coming from this point. Because at this point, MED and MSF or thermal technology traditional and RO, it has material, membrane or a tube. And my project cancel this material inside membrane or tubes. Then if we cancel this, capital or capital and maintenance cost, it will be reduced. Then it can no fouling and no chemical, and we don't use a lot chemical use for this technology. In simple, this technology only hollow chambers, no material side, low capital cost and operation cost. It can used without fouling and no scaling, and the temperature lower than traditional thermal technology, because MED are around 90 and for MSF around 120. But for this technology, it can from 60 to 74 feet water. It can use or can deal with high salinity for seawater or analytical for condition for seawater. The internal heat recovery up to 70 by multi-stage. That means only use the spray inside evaporator or a chamber, evaporator chamber. This technology, we can use this video. We can see two chambers connected together by one tube. In left side evaporator code, feed water inlet. The difference between pressure and temperature between chamber inside and feed water, the droplet, it will be break up and translate from heat from liquid state to vapor state, then evaporate. After that, water vapor, it will be moved from evaporator side to condenser side because different temperature and pressure. Then at the same time, in condenser side, we use the potable water and the feed of potable water lower than between 10 or from 8 to 10 degree lower than evaporator chamber. Then it will be condensed in by droplet. After that, we collect together this potable water and collect inside and go to potable or distillate water. And actually, this technology starts from 1981, but the problem in this from literature review. But the problem for this letter from literature review, the delta T between evaporator and feed water is more than from 10 to 15. And we want to reduce this temperature because we want to reduce the increase the production and we want to use increase the production, and we use this. We use this technology or this device, this micro bubble or nano bubble device introduced inside the droplet. And this patent from 2018 from cows. This, we can see this video. we can see this device, how can it work? It has two tubes, one liquid inlet under the pressure 2 bars, and water vapor inlet from this side. The temperature lower than the feed water temperature by 5 degrees. Then this water is stagnant or backed with stagnant water, then shearing force happens, and the micro nano bubble is created inside droplet. We can see in this video how can shearing force happen between water from micro bubble device and stagnant water. Then the micro nano droplet bubbles inside the droplet, and at the same time use this in one chamber or one tank, use this for feed water to evaporator, and that micro nano bubbles, the temperature or the droplet size is between 10 to 25 micrometer. And at the same time, we use these micro bubbles for experiment. This experiment without micro bubble, we can use this see the distillation production from 3.47 at that degree temperature 38 for feed water to condenser, and feed water, the temperature for feed water to condenser 35, and the production at 3.47 without microbubble, and with microbubble the increase to 4.07, and we continues until the temperature around 90. We use this microbubble device with this direct contact survey of operation. We found the modification, the improvement around from 33 to 35% of production max. After that,
presentation, the doctor.
yes, like this. Sure. And in the for single state, because I did this experiment in cows for single state, and use the temperature, peak temperature for evaporator of from 38 to 60 or 59, different 53 degree. Then and compare with and without evaporator, without the microbubble, and I found the improvement. Yes. 30 to 34 to 35. At the same time, I use for multi-state, but actually I don't have multi-state in cows. I use single state, but I use that for piecewise technique. How can I use this piecewise technique? I use one single state, if 60 inlet and outlet 55. In second time, I use this outlet temperature for inlet. Then I complete. And actually, I finished for 6 states. I found the improvement, the same descent from 30 to 37. I have one graph, but I can't show you.
Yeah, doctor.
Yes.
So we can say it's a similar to emissive technology or
Emissive technology? No.
because principle it's almost
Principle, but that emissive technology use the tubes.
yes.
But this is no tube, no material, no membrane, no tubes. Only hollow chamber. Only we use the spray. This is the benefit. Because the tubes and membrane make a lot of challenge or دي مشكلة بس.
So are you using this for a brine treatment as well?
Yes, we can use, but I use that for deep sea water. In my experiment, I use that deep sea water as a feed.
Your feed is only the Red Sea water.
Yes.
What about the reject of the RO? Do you use that for the
Yes, in environmental documentation, you can use this technology for brine or hybrid system with RO for brine system.
So can you reach to a zero discharge stage with that?
Now go back.
In the moment you get recovery 40%. How far you can go with this?
Again, question please.
You get a recovery of ROs 45, maximum 50. How far you can go? Because you can get that second
Sign in required.
So how far you can go?
With RO.
Or without?
No, without is recovery at around
This is Hassan.
like this around with micro bubbles, 3 point something, 3 point yeah, different station, 3 point something. You can see this here.
As a total questions on the RO recovery itself. Are you going beyond 45%, 50%?
With direct minute. I think I can use this. With only I use this direct with the business ratio increase to 3 point something.
Sorry, Dr. Marish.
We are really sorry for what happened here, but can you please go for conclusion in your own words so people then we can catch there is time for one or two questions. I am sorry for that.
We found the conclusion we found that with microbubble 25 and business ratio for this technology with microbubble is to 3 point something. I didn't remember, but 3 point something. And this technology is better than for the MSF and RO for low capital cost and maintenance cost and low operation cost and without this material side. The heating capacity for multi-stage it will increase up to 70 because the temperature from lower state until lower state it will increase. So we can use this energy for heat exchanger and we can use it. This is my conclusion. Thank you.
I saw your experiment. What is your experiment? Where you
Yeah, we want to build this 4 states now. And actually now we cancel this tube between evaporator and condenser because we want to close the distance between them and we can improvement. And now we will start for 4 states. And actually 4 states, not piecewise state. We will build 4 states in cows and complete this technology and experiment.
Thank you, Dr. Ryan. And again, sorry for
شكرا لكم.
It's good that we have 5 minutes at least to take some questions if you want. Please, Dr.
Regarding your previous session for the desalination, okay, you can give us
دكتور حسن ولا كيم جونغ؟ كيم جونغ ولا دكتور حسن؟ لا كيم جونغ. والله
Kim? Yes, Kim. Can you hear us?
Yes, I can.
ايه طول صوت شوي.
Can you hear me?
Yes.
Yes, my query regarding the total equivalent energy in terms of the electrical consumption and the thermal energy for the heating. As per your conclusion, you already integrated to 5 kilowatt hour cubic meter. So I think in terms of the electric, you already shown to us, but we didn't find in the part regarding the thermal energy consumption in your pilot scale as a desalination, whatever is IND or the other one, PVC.
The equation used is the same. It's still from the basic Carnot heat engines. In other words, we transform using the equivalent Carnot work that produced by normal heat engine to the real processes. Now, in the thermal desalination, the higher temperature reservoir is only about 70 degrees Celsius, while the ambient is 30. So when you take 1 minus T 303, representing in Kelvin, to 353, something like that, or 343, then you find that you can calculate the QSPE required for the same Carnot work. That can be easily done through basic thermodynamics, classical thermodynamics. The only difference is you have to know what is the second law efficiency of the process. And from literature, you can determine the second law efficiency of thermal evaporation and condensation is typically about 70 to 75%. And based on that value, we determine the QSPE for 1 kilowatt hour in the conventional temperature to become 0.1089. This is how it is determined.
Okay, we have a last question with Dr. Ahmed. Yes.
My question to Dr. Son. It was very interesting presentation you have given to us regarding the hybridization between the ND and the FO. But I couldn't read numbers from your presentation, which is very critical in acceleration. First, what is the total energy consumption for both systems, and also what is the total recovery? I couldn't see it during the presentation. Can you elaborate more about this, please?
Yes, thank you for the actually this was a kind of a keynote, so actually I tried to go over briefly about the concept only. Actually, the most of the data, actual data is already 2 papers is already published, and additional papers, 2, 3, 4 papers are in process right now. Soon, hopefully, like you can see the actual data from the paper. But in addition, right now, I briefly mentioned actually the GOR is around actually the FOMD, the mainly thermal, the energy consumption is following to the MD process. In this case, actually, I used like the DCMD, so GOR is hardly the 0.8. It was it wasn't like multi-stage thermal processes, so energy efficiency of MD was very low. But like one thing I want to emphasize, highlight is actually the feed water for the MD what we using was nearly like 100,000 because it was like a produced water. So that is considering that like the GOR was pretty much still high, but like for the particular objective to treating the produced water, like what you are trying to explain, and then also like we can I can answer you more in detail like that.
Yeah, please, we can start together at the break.
I think we are done here. I thank you very much. I firstly thank our speakers and our speakers online. Thank you very much for joining us. Thank you very much for our audience. Hopes to see you in the next session, inshallah. In about 10 minutes time. Thank you.
اقوى عشان الصوت، عشان الصوت يبقى ظبط.
الو بسم الله الرحمن الرحيم والصلاه والسلام على سيدنا محمد اشرف الخلق النبيين. Welcome in our session about desalination. Our first speaker will be Dr. Professor Ibrahim Mumtaz. MashaAllah, Ibrahim Mumtaz, he has a long resume. He has a PhD from Yale University in the year of 1985. He graduated in 1985, but he's still young. Professor Ibrahim is from King Saud University, Riyadh, Saudi Arabia. Ibrahim Mumtaz has since 1979 academic and professional experience in desalination and water treatment field. He has published more than 50 papers in desalination and water treatment. Professor Mumtaz was member of the editorial board of the Desalination Journal, as a real international journal of nuclear desalination and desalination and water treatment. He is a member of IDA and member of the foundation committee of the Arab Water Council. He was member of the executive committee of Prince Sultan Research Center for Environment and Water and Desert, as well as various scientific and professional society. Professor Al-Mumtaz area of expertise include but not limited to the following modeling and modeling of desalination processes. Today, his topic will be about toward developing key performance indicator KPIs for desalination processes. Dr. Ibrahim, floor is yours. You have 20 minutes.
بسم الله الرحمن الرحيم. الحمد لله رب العالمين وصلى الله وسلم على نبينا محمد وآله وصحبه وسلم. My talk today will be about how to develop a KPI for a desalination plant. Actually, every desalination plant has its own specification, and you cannot just find out a specific KPIs for all desalination plants, but I will present here what I can call as the methodology or the method how to develop such an important performance that can monitor the work in the desalination and the achievement in the desalination. As I just mentioned, that the aim of this work is to introduce some KPI principles, which I just mention here very shortly, and it was surveyed in the manuscript. Also, I will show even in more detail in the text how we can utilize the strategic objectives and the goal for the operating of the desalination plant. How can we use such information to develop viable strategic plan, to set initial and programs, to achieve certain objective and goal in the field of the desalination. Eventually, the paper actually will end up by selecting some key performance indicators that it can be monitor the work in the desalination plant. The content of the presentation is very short, a short introduction, and I'll talk a little bit about developing the strategic plan, and then I'll review just the name of some strategic plans that have been laid or produced in the Saudi Arabia. And as I mentioned, I will mention repeatedly that the whole detail is in the manuscript. Then at the end, after reviewing such a strategic plan which been developed from different water sector in Saudi Arabia, I will just mention some KPIs and then the conclusion. Needless to say that what is the meaning of the KPI? When I mentioned to some of my students, الصوت يقول لكن يحتاج إلى الرفع موجود. الآن الصوت أوضح. كويس. طيب أنا كنت ماسك الميكروفون وهذا يعني work without any benefit. This is the lost. I'm just saying that when I mentioned the KPIs for my students, they said this is you have to feel backward or something. That this is a very well-known thing that you have to think twice to represent the meaning of the principle of the KPI. This is something already known. Anyhow, it's still as a monitoring items for in industry and also in many other activities. So it is the KPI is part of the strategic management. It provides information to exhibit the workability of the industry, the institute, and can be defined also the KPI, a measurable value that is used to demonstrate the objective, how these objectives are being achieved. KPIs had to be counted and had to be compared with something that is acceptable or non-acceptable or refer to some benchmark. It should be evidence, and no KPI is just laid for no time. It had to be bounded by specific time. Also, the KPI had to have some requirement. It should represent the target effectively, had to be simple and easy to interrupt. Also, it should be able to indicate the time trend. Also, the KPI had to be so reactive that respond to the changes in the organization, in the industry, in the institute. It had to also relevant to the data collection and data processing, and should be easy to handle such data. And the last thing, it had to be updated, and the update had to be so quickly that will interact with the institute or the industry. Successful KPI actually depend heavily on the objective and the goal, and the objective had to be smart, specific, measurable, achievable, relevant, and time bound. That was just a little bit of educational, if I can say. Then I go to the development of the strategic. This is the basic aim actually to establish definitely the nature and the characteristic of the organization and the sector that represent the management of this sector. So a strategic plan is an integrated goal of operational objective, programs, activities needed to be achieved in a desired result. Every organization, even desalination, including desalination industry, have to have some mission and vision. And the characteristic of the strategic plan, it should consider the environment within the workability of this plant and provide a mid-term framework for the organization. It had to be, as I mentioned before, dynamic. It had to respond quickly and easily, and also updated in the same manner. It is the basic of the allocation of the resources. It had to be within the resources. A strategic plan that beyond the resources of an organization, it is not strategic. There is a difference actually between the strategic planning and the long-term plan. And I just put this table to show you actually the difference, the basic difference between the strategic and plan and the long-term plan is the time. Long-term plan, whatever the longevity of it, it is bounded with time. Strategic plan had to be forever, for the ambitious and goal that had to be achieved. So this is just a table show you the difference between the two concepts. One of the procedures that had to be conducted, starting from the vision and the mission, you have to carry out what we call a SWOT analysis. And this is included in the stages where the strategic plan had to be developed and the initial basis to convert the mission and the vision of the institute. Third part of this also, I just review in the paper intensively in deep the Saudi national water plans that have been conducted in the past, starting with the plan that called assessment and the strategic plan, which was conducted in 2010 by GTC International, and then also the 2014 National Water Strategy, which was working or planning for long term. Eventually, it was not come up for approval. That's two strategic plan, which was conducted in Saudi Arabia. The third one is the Unified Water Strategy for the GCC country, which Dr. Muhammad was laughing that he was part of it, and I am honored also to be part of it. And it was supervised by Dr. Abdulaziz Al-Turbaq and Walid Al-Zubari. And I review also in the paper this work. The aim of this plan to develop a comprehensive and unified water strategy in the GCC country for the next 20 years, to establish an office of strategic management in the GCC country to implement, update, and unified water strategy. At the end also of reviewing this strategic, we are now having an intensive and wonderful and informative and very comprehensive Saudi National Water Strategy 2030. This plan was developed by Buzz Allen Hamilton for the Ministry of environment and water and agriculture. And this is so comprehensive. It's laid into 5 strategic objectives, which is you can read in here. So through this strategic plan, which was developed in the past in Saudi Arabia, I collect one more. Sorry, also I review the saline water conversion corporation strategic goals. SWIC produce some strategic actually goals which I go through it as well as the other plan. So this is the procedures that's starting from the principles, goes to the development of the strategy, then review the strategic plan that was developed in Saudi Arabia, come up with this short list actually of the KPI, which is the availability factor, capacity factor, recovery ratio, reliability, and thermal efficiency, product quality. And the last one, I think if you like to know it, I should hide it. It is the water unit cost, water cost. Also, there is a study by ICRA, which developed some KPIs. I review that, and they mentioned some KPIs, as you can see in the table: plant life, and also product quality, plant availability, product capacity, and for the thermal specific diesel MSF plant, the GOR, and the lost time, injury frequency rate, safety, and the maintenance and corrective maintenance also, and then the non-fuel operating cost and the environment legislation. Glad to come to the conclusion before you stop me. So, as I mentioned before, KPI is one important part of the strategic system. It provides information whether the strategy or the strategic plan are working, and program objective and goal are comprehensive. The KPI also with the strategic plan identify the goal, strategy, objective, and then by that KPIs is developed. General overview of desalination, which were indicated or developed in various Saudi national plant, was highlighted, as I mentioned, 4 of them. Eventually, these are the KPIs, and then the development of the KPI for desalination had to be matched with both 2 things, the benchmark and the time bound. And target time bound had to be specified. Thank you very much.
Thank you very much. We'll have the question at the end of the session. Thank you very much.
Now, our presenter, Dr. Mohammed Shahzad. Dr. Mohammed Shahzad is working as a senior lecturer in mechanical and construction engineering department at Northumbria University in Newcastle in the United Kingdom. And also he is working in hybrid desalination process. Dr. Mohammed, he will talk about unlocking the desalination process, the future roadmap. Online.
Thank you very much. Assalamu alaikum and good morning, everyone. Today I will be presenting about unlocking the desalination process future roadmap. And I am Mohammad Vakil Shahzad and working as a senior lecturer at Northumbria University, UK. So I would like to start with the United Nations Sustainability Development Goals, because this is very important to link with the water. So as we all know that there are the 17 goals and containing 169 targets. But if we zoom into all these 17 goals, actually 3 are the major goals. Those are interlinked between these 17 goals. So those 3 goals are, one is a water and sanitation, affordable energy, and climate action, because these 3 are the major goals that control all 17 goals. But even within these 3 goals, if we look carefully, the water is actually a major content that also control the energy part, because energy production also need water, and also it control the environmental the climate actions, because as we know the water evaporate and condense and fall as a rain, so it also have a great impact on the climate action. So we can say that out of 17 goals, the water is a major goal that actually control most of the targets and the goals. But unfortunately, we can see that the water is actually depleting all over the world. And we can see the most of the part are actually under the water stress umbrella. And desalination is the only solution, practical and the viable solution to fulfill the supply and the demand gap. And it's also not new, because it started from 1985 or even before. And we can see that today around 20,000 or over 19,000 desalination plants, they are producing around 30,000 million gallon water per day. And major water desalination processes are installed in the Gulf countries, that is over 65%. And as we know that the desalination plants, they can be categorized in many different categories, but unfortunately, all the desalination plants today, they are operating only at 10 to 13% of thermodynamic limit. And that is quite shocking figure, because if we see the literature, everyone is claiming that they are operating at very high efficient process. So the 10 to 13% operational limit is because of their operational constraints. And as we can see, there are the 2 major desalination process, that is a reverse osmosis and the thermal desalination. So the reverse osmosis process, they have their limitation because of their water quality, like red tides or the algae blooms. They actually can fall the membrane and block the pores. And similarly, the thermal desalination process, they have the problem of the operation in terms of high temperature and the low temperature. So these are the operational constraints that actually bound their performance from 10 to 13% of their operational limits. But as I mentioned, if we look into the literature, you can see a lot of papers on SWRO. They are claiming that the plant are operating at highly efficient manner. And similarly, the thermal desalination plants, they are also claiming the same. So now the question is that which plant is, or which process is more efficient, or which process is able to improve more in future. So to get the answer, we look back into the history, because we don't want to invent the wheel. We want to learn from the people experience. So as we know, the desalination was started in 15th century when the ship was sailing in the sea. So they were producing the water with the open distiller. And at that time, the performance was very low because it was an open fire burning. And then there was an improvement in the process because of the boiler technology, the efficient burning process. And then the MED and MSF, the multi-effect distillation process, they came into the market. And then there was a performance improvement again in somewhere early 90s. And then the last jump was observed when RO process and also the combination of desalination and the power process that came into the market, and the hybrid process. And at that time, that was the last jump that was observed. And after that, there's a gradual improvement, but there was no big jump was observed in the performance. So it means we can clearly see, or we can learn the lesson from this trend that the high jump in the performance can only be achieved if we change the technology. If we keep the technology, just improving the process or the material will not give us the big jump in the performance. So we started looking into the limitation of the conventional desalination process so that we can see that how we can improve the process, or we can come up with out-of-box solution. So firstly, as I mentioned, the thermal desalination process, the operation is limited by the top brine temperature because of the scaling or the falling, and also the low brine are the lower temperature, and that is because of the seawater cold condenser. And similarly, the reverse osmosis process, they are also limited by the water quality, like a red tide, the algae blooms. But thermal desalination process, they have the advantage of the robustness, because with the change in the water quality, their distillate production quality don't change much, and also their operation don't change much if the water quality change. So we started working on the thermal desalination process, that how we can improve. Another advantage is that because it can be linked to the solar thermal and also the waste heat from the industries. So it has many advantages over the RO process. So conventionally, the thermal desalination process, the heat is supplied from the heat source, and then it's supplied to the tube side, and the feed water is sprayed on the surfaces, and the evaporation is used as a heat in the next or the successive stages. So this process, the evaporation and the condensation continues until the last stage, and the last stage vapor are condensed in the condenser. So we can see the clear limitation of the top brine temperature, that is a heat supplied, and the low brine temperature, that is a condenser. So we come up with a solution that we can bypass this condenser, and we introduce the adsorption cycle, so that the vapors from the last stage, it will be adsorbed on the silica gel. So by this, we can actually bypass the condenser, and we can bring down the last stage temperature to as low as 7 to 5 degrees centigrade. So it means, as compared to the conventional system that is operating from 65 degree to 40 degrees centigrade, we can operate from 65 degree to 15 degree, or maybe less than 10 degrees centigrade, because conventionally the adsorption cycle is used as a chiller. So it means we can go as low as 5 degrees centigrade. So to demonstrate this concept, we built a pilot at KAUST, King Abdullah University of Science and Technology, Saudi Arabia, because I worked over there 5 years as a research scientist. So you can see over there, this is the adsorption cycle, and 4-bed adsorption cycle. And then on top of that, we build a mezzanine floor, and we build the MED cycle that is connected to the adsorption cycle through the pipes. And the system is operating with the solar evacuator tube collectors, as you can see, that is on the one of the rooftop. And this pilot capacity is at 10,000 liters per day, and the evacuator tube collector are 352 meter square area. And this is the operational HMI of the system. So here are the results. So we can see very clearly. So this shows the water production with the heat source temperatures. So the green line shows the water production of the conventional MED system, and the red line shows the water production of our hybrid system. So we can see very clearly that the water production was improved more than twofold at the same at all heat source temperatures. And in addition, our system has no limitation of 40 degree. It can go as low as 10 to 15 degrees centigrade with the same heat source input. And that was one of the reasons to improve in the water production, because of the flushing effect. So after this successful demonstration, we realized that there can be another hybridization, that we call it as a tri-hybrid system, because we know the membrane distillation is operating with the hot front and the cold front. So we realized that our system has excellent hot front, hot water or the brine that is coming out from the first stages of the MED, and the cold front, the distillate that is at lower than 20 degrees centigrade temperature, that is coming from the last stages of MED-AD. So this is an excellent match that can be used in MD system to extract the more water from the rejected brine from the MED-AD system. So we had the MD pilot, that is a MEMSIS, and we hybridized this MD pilot with our MED-AD system. And here are the results. So we can see, so this shows, the gray point shows the vacuum membrane distillation water production, and the red line is the same MED-AD water production. So here is the combination or the comparison of all three systems, that is MED, MED-AD, and the tri-hybrid system. So we can see very clearly that the MED-AD system, the hybrid system, can boost the water production to over twofold as compared to MED system. And the tri-hybrid system achieved 20% additional water as compared to MED-AD system. So it means we are talking about more than twofold water production with the tri-hybrid system. So we also had the life cycle costing analysis. So we can see, as I mentioned, that all the conventional desalination process, they are operating at 10 to 13% of operational limit. So we were able to achieve around 20%, but still it's not a sustainable, as we believe that the sustainability lies if we have water production efficiency more than 30 or 35%, as all the internal combustion engine, they are operating. So the thermal process, they can operate at 30%. And we also calculated the water production cost, and that is around $0.48. That is a lowest water production reported in the literature. So technology was highlighted in many social medias like Nature Middle East, Yahoo Business, New York Times, Arab News. And we also won many awards like Sustainability, Mead Sustainability Award, a Global Innovation Award, IDA Sustainability Award, and Global Energy Globe National Award of Saudi Arabia. With this one, thank you very much.
Thank you very much.
Our next speaker will be Dr. Engineer Amar Mohammed Mahmoud. Engineer Mohammed Mahmoud is a researcher in the DTRI with 17 years experience working in many projects in water desalination. And he has 2 patents, participated in publishing 18 papers in water desalination. Engineer Mahmoud, you have 15 minutes. And welcome. Stage is yours. Can you hear us?
Thank you very much for your kind introduction to me. I just will share my screen. My screen is clear to you now?
Yes. Yes. Yes.
Okay. So today I will speak about high temperature multi-effect desalination at 95 degrees. Sorry?
Maximize the PowerPoint.
Ah, sorry.
Okay. Full screen. Okay.
Okay.
Lovely.
So today we will speak about high temperature multi-effect desalination 95 degree demonstration in DTRI pilot planet in Jubail, Saudi Arabia. So as the draft we received, I will make introduction and then discuss the methodology we have used and the result we have gained, and finally conclusion. So in this curve, I summarized the technologies of desalination in terms of reliability and efficiency. As we can see, MSF has the highest reliability of operation, so it can withstand with the harsh condition of seawater, and then it comes with MED TVC and RO, and then RO. And membrane distillation and forward osmosis is still under research. But RO has the most energy efficient technology yet. So now we are trying to shift MED TVC to be more energy efficient by this research project. For Gulf area, we have, unfortunately, the water condition is very unacceptable by different technologies. So it has very high TDS, it has very high turbidity and total dissolved solid with a high temperature range between 15 degrees in winter and 35 in summer. Comparing to other seawater composition, we can see here the condition of seawater in Gulf compared to other areas. So RO has a lot of challenges to operate within Gulf water condition, and it's need a lot of pre-water treatment. So if we talk about salinity, we have the highest salinity in the world, around 45,000 ppm. Some areas have even more. Turbidity is between 5 to 12, sometimes NTU, and sometimes reach even 50. Total dissolved solid also red tide, which happen occasionally and need some special treatment for RO, which is DEF. So this all will reflect in the RO cost. So, and if you want to implement thermal, it's again a question of efficiency. So this research, as I mentioned in the beginning, we're trying to go to thermal with highest efficiency we can go. Just for introduction, I will explain how MEDs work. Seawater is coming from the, as a one-source route, comes from seawater with a concentration of 1, and then sprayed in parallel in different effect. As you can see, the shower, it showers the water above the tubes. The steam comes, which is a heat source to the system from outside the effect, from the TVC or from the previous effect. So the steam will go inside the tubes and heat up the seawater to evaporate. And then this vapor will drive the production in second effect. Currently, we can see, as I mentioned in the first slide, MED has more efficient than MSF. But its working range temperature between 65 and 45 degrees almost, with GOR around of 10. So if we can increase the TBT to higher temperature, it will give us more effect, so we can reuse the vapor and give us more efficient operation. So if we increase the TBT to 85, the GOR can be increased to 15 and even more. This is just conservative values. And if we have 95, we will have even more effects with more gain output ratio, which is the efficiency of the system. And of course, the cost of steam will be less by this way, because we are utilizing the energy much more times. So the cost of steam will be less, which is the dominant in the thermal desalination. Almost 50% from operation cost is related to steam cost. As you can see here from these graphs, it's a breakdown from the cost for different technology. The steam cost here, as I mentioned, is almost like 40% from the total cost and more than half from the operation cost. That's why this is also driven to us to try to increase the efficiency of MED by increasing the TBT, which is top brine temperature, maximum temperature in the system. So this project actually we started earlier in different steps. We gradually increasing the temperature from 65 to 85. And now we have one jump step also for 95 with acid dosing last 2 years back. And the latest research now is using only anti-scalant technique. No, without using any acid, because acid has bad effect by corrosion, and it's even we was surprised it's even more costly than the anti-scalant. So we tested the operation condition at 95 degrees with the pilot test skid, which is oriented in Jubail in Saudi Arabia. With this configuration, we have capacity of 1.3 ton per hour. Brine recirculation. Actually, in this case, we in normal MED we have once through operation, but to simulate the commercial planet, we want to increase the salinity to up to 65 degrees, 65,000 ppm, because in commercial planet it has more concentration ratio. So we made brine recycle to increase the salinity and simulate the worst condition in the commercial plant. We have only 4 effects. Tube material is titanium, and the number of bases is 2, and the tray is perforated plate. So we went to 4 months scale test evaluation. Top brine temperature 95 degrees, bottom brine temperature is 88 degrees, because we have limited heat transfer area with this pilot, and this will confirm also our theory. Total feed supply is 35 ton per hour within 60 and 63,000 ppm, which achieve us in the bottom perforated tubes here in at higher around 65,000. So it will simulate exactly the commercial plant, and we have distillate around 1 ton. per hour. This is just a simple diagram to showing how it works. So seawater is coming and it's mixed with brine, which is coming from last effect, and go and feed parallelly to all effects together and heated by the steam which is coming from the boiler, and then mix it with the steam which is extracted from last effect, and then go as this is the heat driven for first effect. And the vapor will go from stage to from effect to effect, and finally the brine will split again, one to feed seawater and one to drain. After as I mentioned, we demonstrate the test for 4 months. We ensure the system was stable. Only thing we have like increasing in feed salinity because of seasonal change of seawater. But it was good for us to check it in different condition. And based on the analysis, mean temperature difference, overall heat transfer coefficient, fouling factor was almost stable without any issue. And after we finished the test, we made visual inspections. The tube was very clean with very thin layer of soft scale, which easy even removed by tap water cleaning. We made calculation for the economics for MED. It's very conservative calculation with which we can achieve more, but we want to be conservative at this stage. We have like 30% saving in steam cost, which will give us around like 10% saving in the total cost, and it will be more very competitive to RO. So as a conclusion, so we made this kind of verification at 85 degree and 95 degree, we can achieve higher performance ratio and up to 40% less steam consumption. And after monitoring the heat transfer coefficient and fouling factor for this 4 months, the graph was very consistent. Visual inspection ensure our results. And based on this test, now we are going as a second step, because as I mentioned in the beginning, this is pilot scale. Although we have simulation for the harsh condition in the commercial planet, but still we already choose the worst salinity, and we have very low liquid loading for the tubes. But as we can understand, the number of tubes is less because this is pilot. So the vapor and water will have homogeneous distribution inside the tube bundle. So as a second step, we are now working to verify it with one of our satellite planet in Western province in Saudi Arabia. And after that, we can go for commercial size. I hope it was very brief to you and understood. Thank you very much.
Thank you. On time. Thank you very much. We'll have now our last presenter.
Now our presenter, Dr. Riyadh al-Mansour. Riyadh al-Mansour expects research and professorship in the field of desalination process, high thermodynamic analysis, as well as on renewable energy allocation. He will talk about performance and cost analysis of hybrid diesel EV powered small brackish water RO system.
Notice. please. The third one.
Doctor.
No, no. Not this. Just no. Third one, no? Third one. Yeah, to be third. To be third.
اوكي دكتور محمد.
No, no, no. كده بالنص.
مع حضرتك على فلاشة. متوفر على فلاشة.
دي بعدتها. على الكمبيوتر.
الكمبيوتر حضرتك ده البوزيشن اللي موجود معانا. اسم حضرتك يا دكتور؟
رضا الناصر.
رضا الناصر.
رقم كام؟ رقم 2 رقم 1 هو ده رقم 2 المفروض ينزل رقم 3 مش موجود
هي دي يا دكتور. كده
انا عارف ليه
يا دكتور.
تفضل دكتور.
السلام عليكم. Sorry for this. Dear gentlemen, madams, thank you for giving me the opportunity to present performance and cost analysis hybrid diesel PV powered for ARU for small community in Saudi Arabia. I will start with introduction, general overview on this of desalination and renewable energy technology, and after that, I will model the diesel PV powered brackish water ARU, and I will conduct performance and cost analysis, and finally, sensitivity study of variation of ARU configuration and fuel cost and levelized cost of water and electricity will be discussed and commented. Introduction, as you know, there is a rapid increase in population, agriculture, growth of an industry and development in the one slide. And on the other hand, there is depletion of groundwater resources and low rainfall and precipitation. This is lead to an increase in water demand in general. Desalination, thermal or membrane-based desalination is a solution or technique to desalinate the water, especially in Saudi Arabia. They leads the desalination market with more than 20% of desalination capacity, and the water demand will increase in next years. For example, in 2023, the global water consumption is expected to increase by 85%. This is compared to 2014. And in Saudi Arabia, the desalination capacity will increase more than 45%. Now we 10.5, the planned capacity 10.3, 10.1, and they will increase by 2023 to 12.3 million liters per day. As you know, desalination process are energy consumption and high cost, particularly in arid and rural regions. For large scale, large city, the infrastructure for power and desalination is well developed, okay? And the water and the electricity is available with low cost. The problem for small community off-grid, national grid, electricity and water. This is the big problem, and the cost of the water in this area is very high. That's why they need to develop alternative and sustainable energy resource. As you know, Saudi Arabia has a large solar energy with more than 2,000 kilowatt hour per square meter as solar radiation. And now the future project is to increase the renewable energy share. Under the Vision 2023, the more than 20 gigawatt on PV. Normally this is will install it, and 2030. Okay. Okay. By 23, the 40 gigawatt will be came from solar PV. For new project, for example, new 100C projects, one target is 1% of renewable energy. And also recently, for more than 50% of energy sources should be powered by renewable energy by 2030 in Saudi Arabia. We choose the PV arrow because there is a lot of advantages of the photovoltaic compared to CSP, especially for the small area. The PV panels are modular, low maintenance, well matched to load, and the levelized cost, capital cost, including WS, is very low compared to the other solar technology like CSP, linear flaring, or parabolic trough, or dam. Okay. For the arrow, this is the main advantage. The specific energy requirement is reduced during the last 10 years because the improvement in the membrane and there is optimization of the configuration. The arrow plant is normally operated at ambient temperature. There is no problem of scale and corrosion. What this challenge we can encounter in thermal MSF or MED desalination. Here the description of the system. For energy sources, there is diesel. For renewable energy, photovoltaic with the auxiliary batteries and MPPT and converter and so on. And for the arrow, there is variable frequency devices and pre-treatment system and high pressure pump. The flow chart for the hybrid diesel PV system design is presented here. We start by evaluating the water needs based in water product and demand, the quality of water, and we design the arrow desalination by determining the arrow configuration, one stage, two stage, one pass to pass, and number of modules and the specification of the arrow modules. After we calculate the brackish water energy requirement, and by determining energy requirement and based on solar resources, we can design the PV and diesel arrow system, energy source system. After we conduct performance analysis and simulation using Homer to find out the best configuration in terms of the lowest levelized cost of water. And we can determine levelized cost of electricity, levelized cost of water, and CO2 footprint safe when using renewable energy. For as case study, Amruj city, the objective is to desalinate brackish water with 6,000 ppm to provide fresh water for a population about 1,000 person. For two options for drinking with quality less than 500 ppm, and for municipal household for dry for washing, and this requirement is less than 1,000 ppm. This is located close to Amruj in the west area of Saudi Arabia. Okay, and characterized by relatively high solar radiation, about 5.6 kilowatt hour per square meter per day. Okay. Based on the water requirement in terms of quality and flow rate, we can design the RO unit. It's single stage brackish water with energy recovery system, and there is option without energy recovery system, and there is 30 elements brackish water RO, 5 vessels, each vessel contains 6 elements. We fixed the recovery ratio 50%. For the PVs, monocrystalline plate with efficiency 70%, and we include also the effect of the heat losses by 0.45% for each degree increase, each degree above the TC, the standard condition 25 degrees, and 1.2 for the density of the air. We choose for the battery lead acid type and diesel 47 kilowatt. Before the optimization, when we do the simulation, we can save about 9% of raw water. This is the pass directly to the household tank without treatment, and we can save about 8% of high energy consumption from high pressure pump. Here the configuration under HOMA. The solar system consists of conventional solar generator diesel and PV panel with converter and batteries, and for PV as considered for renewable energy. For the input data, here especially for the development of cost model. Okay, this is based in real quotation in KSE. For the PV, the cost of the PV change with the capacity. For more than 100 kilowatt, it can reach $1.5 for 1 watt. Okay. For larger capacity, the PV cost, including PV with the balance of material, we can reach less than $1 per kilowatt. Here are some results. I present the annual analyzed cost, capital cost, okay, with the renewable energy share. And we observed that for zero renewable energy share, that means 100% energy powered by diesel. Okay, the annual cost is very low, especially because the cost of the diesel and the cost of the fuel diesel, which fixed at $0.13 per liter. When we increase the renewable energy share, the cost associated with the renewable energy increase also, and we reach maximum about 25 to 35%. There is another optimum where the annual cost is very low, for about 85%, and this is because they reduced of the number of battery. For the PV cost, mainly the cost of the PV and the battery, this is the affect the cost of energy system. Okay. Hey, also, I draw on the left the levelized cost of electricity, which vary from 0.12 kilowatt to 0.18, $19 per 1 kilowatt hour. Based on this data, we can do the levelized cost of water, okay, which present in function of renewable penetration, and we distinct there is minimum to optimum without using renewable energy, and this is, as I explained, because the fuel cell cost, which is taken this consideration very low, there is 13 cents per liter. Also at about 85%, because the number of batteries is very low compared to just one battery they used for this case. Okay. Here, sensitivity study was conducted to study the effect of number of stage of RO and the energy recovery devices on water cost. On observe on general, adding the second stage for RO, we can reduce the energy consumption and increase recovery ratio by about 15%. And this is affect positively on the levelized cost of water as shown in this figure. Due to initial investment of the ARD system, the configuration with ARD or PX, kind of energy recovery devices, the levelized cost in this case is the highest. Here, the effect of fuel price on water cost. We can observe that the price of the fuel, this is the high impact on the water cost in general, and also for the configuration with the 2 stages. This is the lowest levelized cost for all the fuel price variations. Also, we observed that there is break-even point using the configuration 1 stage with ARD for fuel price correspond to 40 cents per liter. In this case, using for more than 0.40 cents per liter, using RO 1 stage with ARD is cost effective. As conclusion, supplying fresh water to small rural community in KSC was studied and performed, analyzed. The power cost has the highest share contribution to the total cost of water protection with about 65%, and for the RO desalination only 30% for brackish water. This ratio increased with seawater, RO. Levelized cost, electricity and levelized cost of water for different combination range from 0.12 to 0.80 dollar per kilowatt hour and 0.809 dollar per cubic meter. 2-stage RO configuration, positive effective recovery ratio, leading to reduction in levelized cost of water. For the integration of pressure exchanger, ARD, it demonstrates that the cost-effective solution for the diesel price higher than 14 cents dollar per liter. Okay, the author would like to give you the
Thank you, Dr. Robert. Excellent presentation. No problem. Excellent presentation. Thank you very much. Question? Now we will open the floor for the question. First question will be Dr.
Thank you very much. Mike.
Thank you. Seems thank you very much, Dr. Rida, for this excellent presentation. Actually, the move towards renewable energy is a must in this region. I have 2 questions. The first question is why you are considering diesel instead of a hybrid system with electricity connection to the grid.
Okay.
And the second is, what if you just desalinate during daytime and you store water, so you increase your PV cells, you increase your renewable energy, you store water at night, and you don't recur to any other sort of energy except the solar energy. Thanks.
For the first question, we consider the small community where off-grid electricity and water. Okay, this is the second option. We consider this, and to avoid the problem or to follow up the load issue. For there is different techniques. The first is use on grid. Okay, for example, during the daytime, the RO is provided by solar energy, and the night and the other they use the conventional diesel or from SEC electricity network. The second option is to oversizing the RO and do the storage. This is what I did here, and I included the cost of the tanks, because in this case we increase the storage water. The third option is storage electricity, and in this case we need a lot of batteries, and this is highly costly. This is in general what I did. Thank you for it.
Any other question?
Yes, please. Assalamu alaikum. Regarding the PV cost capacity, which you already concluded from the pilot scale as a $2,000 in average per kilowatt, this one, there's no any commercial figures can be compared with this figure.
Yeah, as I presented here, the cost is the cost of the PV, including BBOS, the inverter, and so on, change with the capacity. For small scale is high. It can reach 2,000 to 2,500. Okay, but small scale is true. They will increase with the capacity. Okay, the price. For the comparison, it's right. For large scale, it's about 1,000. I worked with a lot of projects. Or here in Saudi, it's about 1 kilo, yeah, 1,000. Yeah. For more than 1 megawatt. For small unit, is exponential. Question, just the recommendation here, the utilization of renewable energy to power the RO is not new, but we need long-term performance to exactly to know the real problem, the effect of the variable load on the membrane. It's a mechanical problem, how to stop it, to start it, because the RO is more complicated. We need when we stop it, we do, for example, we have to do the flashing. This is there is one I think pilot in chip. We do the automatic flashing to remove all the particles in the membrane. We need this kind of study to first to evaluate correctly the cost. Second, to examine what the operational problem. This is especially with the variation of solar radiation and so the sky, the effect of this environment, yeah, this will affect very
the area of the, if you take this in the west, often west, so you find that this one as a sandstone and also affected with the planets will be affected.
Yeah, sure.
I think you should take into consideration the pipe at least 1 year.
Yeah, at least.
Yeah, for taking the weather effects.
The effect
and also sometimes changing in the areas.
More problem close to the sea. That there is the dust accumulation there, so this is could affect the performance efficiency of the PV. How to remove this? This is another thing. Based, for example, for solar radiation, we found. I worked previously in Lausanne. We found the solar radiation close to the sea is down about 20% compared to the other, especially because the humidity effect and the so we should include it here. For the new project from the Arab project, Saudi project, but they consider also energy protection. That's why 100% renewable, not just PV.
You are taking consideration regarding the carbon effect of the manufacturing of the solar panels. Almost now, the consultants working there, they are taking this life cycle also. They are taking, as you know, as a like this is how to consider the production during the processing of the manufacturing of the panel.
Exactly. Maybe we should do like nuclear for the deposit, for the nuclear they include in the capital cost from the beginning. But we have problem for the discharge for the arrow rate because it's fabricated from polymer out of the deposit, especially here in Saudi Arabia, the replacement of the arrow each 2 years. And there is I visited there are 1,000 and WSTA. This is from also the same for the PV. How to after 25, 30 years, maybe 25, the life cycle of the PV. What we do with this polymer, and it's not easy to recycle. Maybe this is the approach of nuclear. They included the price, this thing after the end of the contract in the initial capital cost. Okay.
Thank you.
Thank you very much. Robert, is there any other question? Any question? If there is no question, we came to the conclusion of our session. Thank you for everybody in this room and for our colleagues and the presenter from outside of the in Saudi Arabia, from Holland. Thanks for the technology that bring us together. Thank you very much, and hope to see you in next event. Thank you.
in progress.
Doctor.
بسم الله الرحمن الرحيم، الحمد لله رب العالمين وصلى الله وسلم على نبينا محمد. نكمل السيشن نمبر 2 Desalination، والمتحدث الكينوت سبيكر روبن ويلسون from Netherlands. Sustainable desalination, how to produce sufficient water for future while protecting the marine environment. Mr. Robin has about 20 years experience in multi-scale numerical modeling of coastal hydrodynamic, degree blue and outfall. It is working at Netherlands. His research focused on coupling of near field and far field model, used recirculation study for seawater, in-lake and outfall, and degree of blue study on advanced modeling technique, used engineering practice. Mr. Robin had a key role as a project manager in multidisciplinary project considering study of a new reclamation, flushing study, and degrading of sediment dispersion, impact study of power, and desalination recirculation study, mainly in the Middle East, Gulf, and Red Sea. Let me introduce and welcome Mr. Robin. And Mr. Robin, I have a pleasure to ask you to start your keynote speech presentation.
Thank you very much, and I'm honored and happy to be able to give this presentation about the topic of sustainable desalination. Like I said, my name is Robin Moreets. I work at Deltaris, which is a not-for-profit applied research institute in the Netherlands in the fields of water and subsurface. I've been working there in the Middle East Gulf area for about 20 years, and today I would like to share my thoughts about the opportunities for sustainable desalination for a region that has a large dependency on this. So let me see if I can go to the next slide. Yeah, the countries in the Middle East Gulf region, they see a growing population and a need for fresh water because of that. But they also face depleting groundwater levels and, of course, very little rainfall. Therefore, there is almost a complete dependency on the desalination in this region. If we look at the total desalination capacity over the past decades, we've seen exponential growth in capacity and also see that over the past 2 decades, more or less, the contribution of reverse osmosis has grown to about 69% of the total capacity in comparison with other technologies like the thermal desalination. We see this clear trend from thermal desalination technologies like MSF, MED, to seawater reverse osmosis, SWRO. We see that globally, but also specifically in the Middle East Gulf region. This shift technology also results in a trend in the market to decouple energy from the water production. Power and desalination plants were commonly co-located in the past due to the use of thermal energy from the power production process for thermal desalination. However, an RO plant only uses electricity and can therefore be decoupled from a power plant, both technically but also economically. And the latter means that water companies can now develop and operate water plants independently from the power sector. One of the main differences between these technologies for the marine environment is in the effluent of the desalination. Thermal desalination typically has a larger brine flow, often combined with a cooling water flow and with elevated temperatures and a slightly elevated salinity in the order of about 10%. Reverse osmosis effluent typically has no elevated temperature, but a strongly elevated salinity, often in the order of 40 to 50%. But the discharge rate is also much less. So the RO effluent does provide a smaller but denser effluent plume that could result in higher salinity levels near the seabed if it's not properly diluted by an outfall, for example, by means of a diffuser. And this is an important point to keep in mind. In the design and the siting of a new desalination plant, it's important to also predict the dispersion of such an effluent plume in the marine environment. We can do this with numerical hydrodynamic models like the Delft3D model, for example. You can see an example of that here in the animation. These models are typically used to simulate the behavior of that future outfall plume and to give an answer based on two questions. Firstly, does the outfall configuration comply with the environmental criteria in place? And secondly, how much recirculation of effluent towards the plant intake do we expect to optimize the operation of the plant? Well, the modeling of outfalls, they cover a lot of different spatial and temporal scales, and they should also be considered accordingly with suitable models and methodologies. Close to such an outfall, near-field effects play an important role in the mixing of the effluent. Near-field mixing models like CoreMix and CFD, they are required to compute these non-hydrostatic effects accurately. However, these models have a simplified geometry and ambient flow conditions, and they also cover a smaller domain because they're computationally often quite intensive. Further from the outfall away, say from tens of meters to about hundreds of meters and further, far-field models like Delft3D are required to predict this outfall plume behavior and the possible effects on the environment in more detail, and also to ensure a good compliant outfall design. However, there is no single model that can cover these different scales in an efficient way and in an accurate way. So this to integrate these different scales in the modeling, model couplings should be used. Different model couplings can be used depending on the application, and you can see a few in the list here. But using the no actual near-field mixing in the far-field model, like in the first bullet, by just introducing the plume in just the far-field model, is often used, but it's physically incorrect. It's not accurate enough. But on the other end of the coupling spectrum, say, there is a dynamic two-way coupling, which is physically the most comprehensive and accurate method. And this also takes into account the varying ambient conditions of the far field, current stratification, etc., in the near field model, and also takes along part of the entrainment process in the far field model. So that makes it into a very accurate and comprehensive modeling system, which is now used as state of the art. The figures below here, you can see how such a coupling would work. You see on the one hand, you see the plumes on a very small scale compared to the far field results model grid, which is typically on a larger scale. And the coupling is in between those. A little bit more in detail, to allow for these advanced modeling couplings, we developed also a Cosumo coupling interface, as we call it. And this allows for coupling different models like CoreMix and other near-field models to a far-field Delft3D model. And in this, it's important to select a physically suitable location for this model coupling. A location in the plume trajectory where both the near-field model and the far-field model provide a reasonably accurate prediction. You can see that here in the middle picture, you can see a red zone, which is used to be the typical zone of coupling, but actually there's a lot of non-hydrostatic processes still playing a role there. And the blue location is much more the preferred coupling location in that sense. And this is also where a model coupling should take place. And next to that, techniques like the distributed entrainment sinks approach, DISA, as you can see in the lower right, as developed by Choi and Lee in Hong Kong, allow also for the accurate inclusion of the mixing processes and mass balances computed by the near-field model into the far-field model as much as possible. So this makes the whole coupling physically more accurate and also more comprehensive. So these type of modeling couple approaches, they allow for covering these different scales of the outfall plume behavior, as I just described, but also in an efficient and an accurate way in numerical models. But also on an even larger scale, the combined effect of desalination industry, for example, multiple plants in a certain region, should be considered, for example, on a Gulf-wide scale. And also here, longer-term natural effects like evaporation, large-scale circulations, climate change effects play a role. Large-scale models, like the Gulf Community Model, they are available to investigate and study such long-term scenarios, and also provide input to a sustainable national desalination strategy by taking into account all the aspects that are relevant to this. So this animation shows the modeling of salinity in the Gulf with this Gulf community model. The model shows on the animation shows on the left the surface salinities, and on the right the near bed salinities. It shows also the higher salinities in the shallow areas in the UAE western coast. You can see that in the yellow spot, because the high evaporation and shallowness in that area that transport further offshore to the north. And you can also see the exchange of salinity through the Strait of Hormuz, where near the bed the higher salinities flow out of the Gulf, and near the surface lower salinity water is flowing into the Gulf again. So this model also includes, for example, the desalination plants around the Gulf, and can also be used for larger scale and longer term studies. Important questions, for example, that currently play in the Gulf region are still subject to this type of research. For example, does climate change have a larger impact on the Gulf salinity, or does the increasing desalination capacity have a larger impact? Well, our first research shows that closer to desalination plants, an increase in capacity shows a larger impact, but in areas without brine discharges, climate change shows a larger impact. But if you look at a Gulf-wide scale, differences they average out a little bit more. But regional differences can still be expected. And also possible changes in circulations could occur that increase salinity and the variability in salinity in some regions, but also reduce salinity on average and slightly in other areas. And knowledge from such research could also inform desalination strategies, and also can be downscaled. These models can be downscaled again to plant level to also in detail look at the vicinity of the plant directly. This type of research we do with initiatives like the Gulf Model Community, which is an open community that shares models and knowledge on the Gulf and also facilitates collaboration in this field. The Gulf Model Community allows us to work together with local institutes and stakeholders on important topics such as climate change adaptation, water safety. And with a community like this, different researchers and stakeholders can start research projects from an established joint modeling base without having to reinvent the wheel again and again, and also without having to make their own models first. They can use the model this as a basis and work from there. So we already have been working with different partners in the region, and we're also interested to collaborate with more partners in this initiative as well. You can see the URL, by the way, of the community model in the lower right. Let's go back to the market, to the desalination, the current market dynamics for desalination plants, really. And it's a point of attention that independent water plants, which are typically now being deployed and built by a consortium of partners and operated by them for decades, they're often awarded the project at the lowest price per cubic meter, rather than with the most sustainable design and operation. And it's actually a challenge, but also an opportunity for water companies to put projects on the market that demands the highest level of sustainability. So, for example, in conjunction with different stakeholders, like environment agencies, local communities, also looking at employment, etc. And look at that in addition to the economic preference only. And steps are being made in the right direction for this, and many innovations are being developed and tested and can promote also this development further. And one example would be sustainable outfall designs. I will touch upon that shortly. But on the other hand, you also see, of course, the introduction of solar power in the desalination industry, which is also a step in that direction. Over the past year, several studies have been carried out to look at the ecological impact of desalination discharges. Now that reverse osmosis desalination plants have been operating for a longer period, ecological impacts can better be assessed. And near the Kaus University in Saudi Arabia, near the RO plant outfall of theirs, a study was done on the sensitivity of corals on elevated salinity levels. The study showed that the corals were not sensitive to even a 25% higher salinity level than the natural background. And this is a much higher percentage than most environmental regulations allow for. Also in Australia, for example, they showed similar conclusions based on extensive ecological monitoring over several years for their desalination plants. So Since not all sites are equal and contain the same habitats, it's important to adopt site-specific and ecologically relevant criteria for desalination brine outfall. Often mixing zone criteria are adopted from other parts in the world with different ecosystems that could either be very harmful to local ecosystems or overly restrictive. Research is needed and also very useful to develop more relevant criteria for certain sites that could be adopted by regulators and increase also the sustainability of desalination in relation to the marine environment. The next step could be the sustainable outfall designs that I already mentioned that, for example, that can double as artificial reefs. So going from environmental impact to bio opportunities, really. Existing outfalls are already often observed as covered with marine life, since it's a hard substrate for life to settle on. And actually outfalls and intakes could also be designed accordingly, with that parameter in mind to promote the right habitat formation at these structures. And with that, other benefits could also be, for example, a higher societal support and a shorter environmental permitting procedure, when opportunities for nature are already created by design by these structures. And even other functions and operations in the project area could be supported with the operation of an outfall. For example, flushing of stagnant areas, and with that improving the water quality. So looking at the development of outfalls from an integral point of view, looking at the opportunities it can bring, it can actually provide a much more sustainable design and operation. Now, research is also being carried out now on the topic on how to promote the creation of habitats around outfalls and other structures. But this is obviously a very complex field that needs careful attention, also to understand ecology well, but also provides great opportunities. So further research and pilot projects are very much needed to optimize an ecological function of structures, of course, in combination with their primary function.
Excuse me, you have 5 minutes, I think.
Yes, I'm almost done. Thank you so much. We can even go one step further. We discussed that in the session in the Dubai World Expo last October. Well, traditionally, we aimed at minimizing impacts on the environment in the past and also on the climate with our marine developments. Today, we try to develop in a climate neutral way. But what if we could develop such a project in a truly climate positive way by actually increasing biodiversity and carbon sequestration with the project? Much research and examples are already available to design each element of a marine development in such a way that we could build back more than there was before. And if such a design philosophy could be adopted, developing marine projects would help to combat climate change while also increasing societal value at the same time. And this will really be the next level in marine development and for the desalination industry in particular. So summarizing, the Gulf region is an economically and environmentally very important area, and water is a crucial component in this. To support sustainable developments of this marine environment, knowledge, data, numerical models are very much needed. And the Gulf model community, for example, facilitates collaboration in this field. Important topics for the marine environment in the region can be studied with such models, such as impact of climate change on desalination and environment, spatial planning of coastal infrastructure, but also flooding risk due to climate change, algae bloom, oil spills, etc. Integral knowledge, combining different disciplines and collaboration between them allow for sustainable development of water resources in the Gulf region, while also creating opportunities for nature. And with that, I would like to thank you for your attention and like have any questions if you have them. Thank you so much.
Okay, thank you very much, Robin. Since we have about 2 minutes, so if there is any quick question.
Yes, Dr. Robin, can you hear me? Can you hear me?
It's very difficult to hear, but let me try.
Okay, now you can hear me well?
Yeah.
Yeah, regarding the modeling or simulation, whatever you have been selected, 3D, I have a query regarding how you simulate the biological contaminations of the microorganisms via the very deep marine outfall, and how can you really have the indicators for the collections? Is it by simulation or sampling analysis or by monitoring. So you have to define the techniques which you have already measured the biological mass effects by the outfall discharge. Thank you.
It's still, sorry, very difficult to hear for me, but your question was about the difference between modeling of, sorry, the combination of modeling and monitoring. Did I understand correctly?
The monitoring technique, I think that also.
You already concluded in your regarding the outfall that you already used some techniques to have the indication of the effect on microorganisms between the aquaculture contaminated by the salinity or by the seawater discharge. So how you measure this? Is it you use the simulation techniques for the kinetics or for the growth, or you used already the stoichiometry or use sampling analysis? How you can measure it? What is the indicator?
On the ecology, you mean?
Yeah.
No, this is a very good question. So there are multiple ways to look at the impacts on ecology in that sense. The research that I showed at Kous University was actually looking at the functioning of the corals that were also placed near the outfall. So they will look at the what's that in English again? The ability of absorbing light and producing food. So they were actually measuring that photosynthetic, that was it, capacity. Other ways of looking at it is indeed the surveying the habitats before and after. And for example, the Australian research has shown they were looking at species composition and abundance around the outfall. So it's basically looking really at what the ecology changes are in the presence of that outfall to see what kind of impact it has. And in the Australian research, for example, it showed that the elevated salinities, of course, it was a diffuser, so it was diluted to a certain extent, but even the elevated salinities did not seem to harm the original habitats that were there. The interesting part there was that of course, if you discharge a brine plume from a diffuser, you push it up and it goes down again and hits the bed. At that point, you of course increase flow velocities and turbulence. So what they saw is that at the location of the plume impact, they saw that the species composition changed.
About this point, please. Thank you.
What is it, sorry?
Yeah, that would be fine, I think, because he asked about the technique for measuring the microorganism. That's just only that. Thank you, Mr. Robert.
Okay, very much. Thank you.
Okay. Our next speaker will be Dr. Thamer Salim Ali Daoud. He will talk about the characterization of the surrounding area of seawater osmosis desalination plant in Bahrain. Dr. Thamer, he is a professor of marine biology in the Arabian Gulf University in Bahrain. He has an extended working experience with the international regional agencies, many of them actually in the state. He had published more than 72 papers supervising master and PhD students. He was appointed by the UNEP as an author contributor for the GE 6/2019 on biodiversity of West Asia region. Currently, he is a consultant at ROPMA on strategic planning of the climate exchange impact on the marine environment. Let's welcome Dr. Thamer. You can proceed and present your presentation.
Okay, thank you. بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. ما أعرف, did you give me the access for the share screen?
Share screen. Share screen.
Share screen. Yes.
Yes. Yes, Dr. Thamer.
Yes. Yes, you already shared. Did he have a good one to share?
Dr. Sawi share screen.
Is it Okay.
No, it disappeared now. Yes.
Okay.
Okay.
Okay. Yes.
Okay. Thank you. As I presented, the paper is concerned with the water mass dynamic change in coastal area in terms of the impacts of seawater reverse osmosis in the east of Bahrain based on tide and seasonal functions. Am I audible?
Yes, you are. If there is a problem, we will notify you.
Okay, okay. Actually, this is the second part of MSc thesis conducted in the Arabian Gulf University. The first one was dealt with the impact on the benthic community, which was submitted to the 13th Gulf Water Conference in Kuwait in 2019. Due to the rapid socioeconomic development in the GCC synchronized with the noticeable increase of population growth, and the growth rate is expected to be increased by 45% during 2015-2050. So this means that the water availability should be provided sufficiently and sustainably to meet the demand. As a result of the scarce surface freshwater in the region, the desalination is the only solution here, using the groundwater and seawater. Currently, the production estimated by 20 million cubic meter per day, and it is expected to increase to 80 million in 2050. As mentioned by Robin in his informative presentation, that since 2010, the RO is the technology adopted for newly plants instead of MSF. The reverse osmosis desalination based on seawater will adversely impact the coastal ecosystem, the water quality, sediment quality, and also the biodiversity. In Bahrain, there are 5 desalination plants with different capacity using different techniques. The one in Sitra, now it's out of work. The case study is on the Al-Dur seawater reverse osmosis desalination plant. By the way, now another desalination plant constructed just south to this one in Al-Dur also. And it will be operated in the next few months this year. So the impacts of desalination activity throughout the GCC marine environment also will be complicated with the climate change if no mitigation in place to avoid the business as usual scenario. Of course, we are aware the necessity of water demand against the such social and environmental conditions, especially when it comes with arid land characterized by extreme dry climate, like the one in the GCC geographical area. However, the protection of the marine environment and the natural resources management is not less important than that. The case study of on Al-Dur seawater reverse osmosis, this plant is located in the southeast coast of Bahrain with a capacity of 220,000 cubic meters. The intake of the plant located at 1.5 kilometers from the plant. However, the brine discharged directly to the coastal area. The intake pipe passed through 4 submerged filtration units located at half kilometer from the plant. There are about 20 barrier fishing traps, and in addition to hundreds of metal wire traps. So this is fishing ground, and it's also considerable fishing ground in the east coast of Bahrain. Adjacent to Al-Dur coast, there is seagrass habitat, and this habitat is of a great biological importance, providing nursery, spawning, and feeding grounds for a broad scale of fishery species. The most important are the charismatic species, the dugong, turtles, dolphins, and also for the shellfish like the pearl oyster. Due to the use of some phosphate compounds for the maintenance of the desalination plant, this compounds released also with the brine to the coastal area. And as you know, the phosphate and nitrate are nutrient supporting the blooming of the algae, and we found a bloom of algal growth along the Al-Dur coast. Here you can see the direct discharge, the track of the brine water directly discharged to the coastal waters. And here there is also an example of frost generated from the cleaning process dumped on the coast. The sampling based on 40 locations selected randomly within the outlet area, including the shallow depth nearby the outlet here, and also the intake 1.5 kilometers from the planet. And these locations are associated with different depths, range between 0.5 to 7 meters, as indicated in this bathymetry map. The Pro DSS multimeter sondes used for in situ water quality measurements, including temperature, salinity, dissolved oxygen, pH, and depth. The sampling based on collecting the readings during 2 seasons, winter and summer 2017, and at each over the tide cycle during the flood, tide, and ebb tide, and at different depths, the surface and bottom, represented by 2 variables, the temperature and salinity, within an area of 1.5 kilometer length and 1.7 kilometer width, approximately 2.3 square kilometers for these 40 locations. So the data analysis scenario 2 by 2 by 2 by 2 with the 40 locations, obtaining 640 values used in the analysis.
We have 5 minutes.
The most important phenomena discussed with the temperature and salinity distribution is the stratification, the thermocline and halocline. Thermocline with the difference more than 3 centigrade, and the halocline with 1 part per thousand. Why stratification? Because this is limiting factor for the distribution of the phytoplankton and zooplankton, the base of the productivity in the ocean. I will start with temperature for the result. This is in winter, the range between 17 to 23. And these are the mapping for the distribution of temperature in winter. The bottom layer warmer than the surface, and weak thermocline occurred within the depths of 3 to 5 meters. As you see that there is no thermocline during the high tide, only in the low tide and within one site around the station 34, where the difference more than 3 centigrade between the surface and the bottom. In summer, the range for temperature between 35 to 40 centigrades, and also the bottom layer are warmer than the surface, and also spatially different based on the distance from the outlet. Here, there is no thermocline formation, neither in the high tide nor in the low tide. That means vertically the water column is well mixed. For saline?
Can you
Sorry?
go to conclusion, yes?
Sorry?
Time is over. Can you go to conclusion, please?
It's less than 15 minutes. You give me 15 minutes. Following to the results obtained, we can conclude that the Al-Dur coastal area is exposed to real impacts, and this will be complicated by the new desalination plant will be operated this year. And the bottom layer within the outlet area are characterized by hypersaline, and this affected the benthic community. The seagrass habitat potentially impacted. This habitat considerably very important as blue carbon sequestration. And it is very important to monitor this by initiating a hydrodynamic model as the one that have explained by Robin, using the two coupling methods, or nearshore and offshore. Okay, so that's all I have. Thank you for listening, and apologize if I was over the time.
Thank you very much. Will we allow one question? Yes, we allow one question. If there is any. We'll try someone else. Is there anybody? Okay.
Thank you, Dr. Kamer. Actually, our concern regarding the algae blooms, which you already indicated by the filamentous. So I think the source of phosphate as a PO4 or nitrate in O3 is from the wastewater, because now in the intake you already implemented 1.5 beneath the water level for take the water for the seawater plants. I think there is no any source of nutrients. So can you explain to us why the algae blooms regarding the eutrophication? Is it based on wastewater discharge in compliance with the environmental regulations in Bahrain and Doral area? Thank you.
Really, I have not heard the questions very well, but I understand that he's asking about the algal bloom, the reason for the algal bloom occurring within. Of course, we have another desalination plants in Bahrain using the MSF, but there is no algal bloom growth have been noticed around this one, just the one here. And when we discussed that with the technicians in the plant, we understand that they use the phosphate. I'm not sure what's the purpose, but this is for the maintenance of the desalination, and this is released by the brine, providing the environment for the blooming the algae in this area.
Thank you very much, Dr. Saad. Our next speaker will be Dr. Ahmed Abu Auf from the Kingdom of Saudi Arabia. He will talk about covering readiness in the seawater desalination sector through geotechnology. Ahmed Abdurrahman Abu Auf, he is a planning and performance specialist, graduated from System Engineering Department in King Fahd University. And 1998, joined the multidisciplinary water, the municipality and water department, and under the Water and Agriculture Ministry in 1999. He was joining the SWIC in 2000, working in the Planning Information Department and the Maintenance Planning Foreman. Since 2008, he joined SWIC also under privatization team. 2014, he obtained a master's degree in industrial engineering from King Abdulaziz University. Let's welcome Mr. Ahmed, and you can proceed with your presentation.
Assalamu alaikum wa rahmatullahi wa barakatuh. I hope you hear my voice clear. Alhamdulillah Rabbil Alameen. Thank you for giving me this opportunity to present my and to share my things with you, and also to take feedback from you. Bismillah wa salatu wa salam. Bismillah wa salatu wa salam. Alhamdulillah Rabbil Alameen. Let's go. My presentation, it's a teamwork. Governing business in the seawater desalination sector through tier-to-tier technology. The agenda, it will be introduction, methodology, result, and of course, conclusion and recommendation. Our introduction will be first problem description, then setting the objective, then the proposed solution. Before I go to, I have a question for you. Anybody knows here about tier technology? Can you raise your hand if you know about tier technology? Right. Bismillah ar-Rahman ar-Rahim. This is simply the tier technology. Any equipment, any asset, it passes through 7 stages: specifications, design, engineering, manufacturing, installation, and commissioning and operation, and finally disposal. The objective of the tier technology is to optimize the life cost of the asset through these stages all life. This is simply, it's a constraint on reliability, maintainability, and what you call it, negative feedback information. You cannot control the operational cost from the last period here. You have volatility, but it will be very weak. You have to do it from early stages, from the stage that you put your specification. When you write your specification, you have to put this on. Also, you have to control it during the design. This is just a simple explanation because it's very important to talk about it. Next step, I'll just give you what you call, look at the big picture. Both tier technology and privatization were initiated from the United Kingdom. We will go through the timeline just to know the origin of things. First, we have the upstream. I call privatization is the upstream because it is about management, strategic management, finance, legal, and tier technology is the downstream because it is concentrated on the equipment. Before the 1945, all services in the UK were private sector owned. After 1945, everything goes to the public, to the government or state or ownership. 1960, this is very important, proceed the Organization of Economic and Operation Development has started. The government of the United Kingdom first is what you call see the they noticed the decrease in efficiency in 1965, 1970. So after that, they make a committee for the Ministry of Technology, and this this committee has studied there was a problem in the there is a losses in the there is a high cost and there is a losses in the profit in the all the industrial part of the country. So they formed a committee. This committee studied and provided and as a result of the study, they have initiated the theory of technology concept. They define it there. There is a PhD dissertation. If you want to read about more technology, it's there. After that, from the 1970 up to 1980, there was a very concerning concern on the technology from the people, industrial and academic. There was a conference, German translated to its language. There was a general journals and papers. After that, when the Thatcher came to the power, she shifted the whole idea by introducing the what you call the privatization concept. So as you see here, the technology, it was a governmental at the beginning, and the academy industry was concerned about it. But at this area, there was no any development. Privatization went on, and the idea of the privatization was for the information idea is to transfer the ownership from the government to the public to the private sector. Both the theory technology and privatization are taking the same problem. What is it? It was economic efficiency. If you go to read in the theory technology, it was talking about economic efficiency. If you also read in the privatization, it will know that it's talking about economic efficiency. Then we proceed. Of course, when you privatize, you transfer the strategic product to the private sector, then there's risk. And the result of that risk from 1980, since the start of privatization, 2008, the first combined code, what is the governance? Remember, our representation is governing the business research sector through technology. So it is three parts: governance and the desalination and the technology. So the first combined code, which is initiated in 2008, OSID made corporate OSID. This is the what we mentioned before. Made the corporate governance. After Margaret Thatcher passed away, she is the first minister to have the ISM, Thatcherism. So because she changed the whole world. Returning to our privatization, see 1993 after the co-organ of Thatcher, first and again the private technology, there was some excesses on that from the UK. The first, if you have a concept, if you want to apply it in the industry, you have to transfer it into standard specification. So the first standard specification for technology was 1993. There was also a return in interest on that. Manchester University made a master's degree in maintenance engineering and asset management. Sweden has made a college called Theory Technology. The British has developed the standard 2008 and produced the life cycle costing. And also, guide to material technology. America itself, okay, 2010 produced the ISO 55000 asset management of renewable soil technology. The idea here, what's the correlation between material technology and privatization? We are tackling the same problem, the economic efficiency. Of course, economic efficiency is wide, but material technology, maybe it's a technical efficiency. Meaning of technical efficiency, you want to reduce cost, improve productivity, and increase productivity, and improve design. This is the aim of the tier technology. The economical efficiency from the privatization is a little bit wide, but it's contained. One part of it is the technical efficiency. I hope this is give you a good picture and clear picture. The objective of our presentation, the main objective, is controlling the whole life asset cost related to the desired efficiency. This is part one. Part two, optimization of total operation and maintenance cost over the equipment life cycle and in the seawater desalination sector. Through what we will do, integrate tier technology system into governing business governing system and code. If we have, for example, in Kingdom Saudi Arabia, a governing system, it has to include inside a tier technology concept to control data. This is the proposed solution. We have, for example, in public-private partnership, many stakeholders: the government, the private sector investor, the lender, the consultant, the contractor, the market organizer, like on our side, in our case in Saudi Arabia, it is ICRA. We have the final customer, and we have the only of the plant. All of them, they have their own interest. So we have to set the goal that adopt all of this interest. This is in a real case example. We have the public sector and private sector, and we have in between them the public-private partnership. The first step, when we are working in independent water and power producer, we have technical investment consortium creation. This will happen in the private sector. The investment proposal, feasibility study, loaning and financing, investor agreement, financial closure, then investor creation. They will wait for the bidding. Bidding will come from the public sector, from the government. They will do the demand supply, as you are doing here. They make the feasibility, then they make the legalization to make the desalination sector open for the private sector, government guarantee, and then bidding start, and they will issue the concept award and RFP invitation. And then the private sector will start the bidding and RFP submission and RFQ submission. Then the BB contract, after the successful bid, then will be the successful contract. Here we'll start the public-private partnership through the what you call SPC creation. SPC creation, special company, special company creation. This special, for example, and we have many cases. And this company will do the ABC project application. They will do the bigger. They will do the RFP application, and they do the contract sign. In this part, tier technology will start. When the bidder do the application, now they putting the specification, doing the engineering, doing the manufacturing, and start the sourcing, because this is creation. Then, after the EPC project finished, start the commissioning, proceed, and this is still are in the system technology. Actually, I just I want to illustrate to you where is the technology can fit in the public-private partnership. Where is this startup? Of course, we have like special formula about system purpose creation. We have the plant creation, and we have the production, operation, maintenance start. The objective of this one, successful process of system performance improvement. This one is a successful transformation. Here is currently here at the ABC. It's a 35 years life program. More as you see, 20 to 30 years. The asset is is in use, and it is with the what's called operation and maintenance system contract. The technology, as we mentioned before, it starts from the plant creation. So as you see, it has to be managed. This it's a program. It's not a project. It's a program. It has to be managed. And this is to clearly exactly what is the task to be done. Business strategy creation, special company creation, then the plant and our number 3 plant creation. Here the ABC project until the commissioning. After that, the operation and maintenance company. This is the maintenance will start to the planning, follow-up, control, the coordination, and the work: mechanical, electrical, instrument, civil, test inspection, material control, all of that. This is at the end, you want to see what is the goals of the privatization of the public project and compare it at the end of the program. After you run the pilot plant, did you achieve the goal? What was set there at the beginning? This is very important. This is the proposed solution. Our methodology, we're not talking just a concept. People have done a job in that. For example, this is the British standard. They said there are two kinds of people, what they call reductionist and system thinking. To work on this, you have to be system thinking. Well, we find the system thinking that you are holistic, systematic, risk-based, optimal, sustainable, and integral. Of course, the American have produced their own asset management. The difference between the British and the English, that the physical, the British are concerned with the physical asset, while the American is any kind of asset. But this one is in general in nature. We need to make what they call specified for the selection sector a technology code, technology standard specification. This is not available in our market. On my no. Yes. Well, I will share this presentation with you now. But I want to say that we have qualitative result and quantitative result. Quantitative result is financial. You can see it. And quantitative, any company does not use this one will be worse than the company that using this one. We have, if we need, as I said, to do a guide for implement technology in our sector, research sector. This is not available. We can do this for WSTA. We can do this for centers in Saudi Arabia and Sweden. These all are centers. The main objective of the conclusion: business strategy has to be aligned with the business strategy. We have this is the strategy talking about making profit and other, while the business strategy somehow is lacking. I want to thank my colleagues. Mr. Khalid Habib is advisor at Quidco, and Mr. Mishal Hassan is operation manager, operation director at Basit Green. Thank you for your listening to me.
Thank you, Dr. Abba. Thank you very much. I think we'll move to the next presentation. Good afternoon. My name is Ali Rada. I could not introduce myself in the beginning. Our next speaker is Mr. Bashir Reka. Are you online with us, Bashir?
Yes, I'm with you, Mr. Ali. Thank you very much.
Okay, thanks, Mr. Bashir. And I'm very sorry for the inconvenience you experienced this time.
No, it's fine. Alhamdulillah, it's fine.
Alhamdulillah. Well, Mr. Bashir is a chemical engineer with a master's degree in chemical engineering from South Africa. He works for the Libyan Advanced Center of Chemical Analysis as a researcher. Of course, his field of research is in environmental implications for desalination and seawater technologies. Mr. Bashir, the floor is yours. Please, we'll start now.
Okay, Mr. Ali, should you share the screen or I should do it my side?
You try from your side, the screen. Share the screen from your side, please.
Let me check.
Any luck?
Can you see it?
No, not yet. Yes, yes.
It's working now?
Yeah, please put it on the show, as a show. Just go to the show icon at the bottom.
Let me check this.
Cut.
It's there?
تحت بشير تحت في السكرين.
Okay.
Show icon.
Okay, let me just, because I'm my laptop stuck now. Let me just.
Oh.
Yeah.
Are you okay now?
I don't see the icon. I'm not sure.
Okay, just leave it like that, Bashir. We are fine. Can you start?
Yes.
Start with your first slide now.
Okay. Okay, assalamu alaikum wa rahmatullah. First of all, I'm very happy to participate in this important event. I will present my paper in Arabic, but the slides are written in English, so it would be fine, I guess. So محتويات العرض عندنا المقدمة، الأهداف، بعدين نبدأ مختصرة عن محطة تحلية تاجورة العاملة بتقنية التناضح العكسي. عندنا تاريخ الأغشية الإسموزية المستخدمة في محطة تاجورة. بعد عندنا الأغشية المستهلكة في محطة تحلية تاجورة، الجزء المعملي، بعض النتائج والمناقشة، خيارات إعادة الاستخدام وإعادة التدوير للأغشية المستهلكة، وختاما عندنا بعض الاستنتاجات والتوصيات. الخلفية العلمية: ازداد الطلب على المياه الصالحة سواء كان للشرب أو للأغراض الزراعية في ليبيا بسبب زيادة عدد السكان وتوسع النشاط الزراعي. لا تزال مشكلة نقص المياه الصالحة للشرب تلقي بظلالها على المواطنين والمقيمين في ليبيا سواء في المدن الكبرى أو البلدات والقرى الصغرى. تعد تقنية تحلية المياه الخيار الثاني من مصادر المياه الغير تقليدية في ليبيا. كأي تقنية كأي تقنية أخرى أو نشاط تجاري آخر، فإن تقنية تحلية المياه لا تخلو من أن يكون لها تأثيرات على البيئة المحيطة. ولعل المحلول أو الرجيع الملحي الذي يتم تصريفه مباشرة في البحر عن طريق محطة التحلية دون أي معالجة يعتبر من المؤثرات البيئية الرئيسية الناتجة من محطات التحلية. إن التخلص الآمن والنظيف للأغشية الإسموزية المستهلكة من محطات التحلية يجب أن يؤخذ بعين الاعتبار عندما يتم التفكير في إنشاء محطات تحلية جديدة. في الوقت الحالي للأسف لا توجد أبحاث ودراسات كثيرة في مجال إعادة استخدام الأغشية القديمة على المستوى المحلي أتحدث، لذلك من المهم فعلا دراسة خيارات التقليل من التأثيرات السلبية للأغشية المستهلكة والبحث عن خيارات لإعادة استخدامها مرة أخرى. أهداف هذه الدراسة: أولاً استعراض الطرق الحالية المستخدمة في التخلص من الأغشية المستهلكة داخل محطة تحلية تاجورة. ثانياً اقتراح عدد من الخيارات والبدائل التي من خلالها يمكن إعادة استخدام هذه الأغشية. نبدأ مختصرا عن محطة تحلية تاجورة العاملة بتقنية التناضح العكسي. تعد محطة تحلية مياه تاجورة العاملة بتقنية الRO أكبر المحطات العاملة بهذه التقنية في ليبيا، بالرغم من أن سعتها التصميمية لا تتجاوز 10,000 متر مكعب في اليوم. بالرغم من أن المحطة دخلت فترة تشغيلها منذ أكثر من 3 عقود، إلا أنه لم يتم إجراء أي دراسات شاملة تتعلق بالآثار البيئية الناتجة عن هذه المحطة، باستثناء الدراسة التي قمنا بها قبل سنوات وشاركنا بها في مؤتمر الخليج الثالث عشر قبل 3 سنوات في دولة الكويت. تاريخ أو الأغشية المستهلكة في محطة تحلية تاجورة. تاريخ الأغشية المستخدمة في محطة تحلية تاجورة، حيث يتم استبدال الأغشية القديمة بأخرى جديدة كل 5 إلى 7 سنوات، وتقدر كمية هذه الأغشية التي تم استخدامها واستبدالها في محطة التحلية منذ سنة 1984 اللي هو تاريخ بداية تشغيل هذه المحطة حتى فترة إنجاز هذه الدراسة بنحو حوالي 8,000 غشاء. أنواع هذه الأغشية مع بيانات لبعض مواصفاتها موضحة في الجدول التالي. بس قبل ذلك أعتقد أني فعلا هذه الشريحة اللي أتحدث عنها. هذا هو الجدول الذي يبين بيانات لبعض مواصفات الأغشية اللي استخدمت في محطة تحلية تاجورة من سنة 1984 إلى حين سنة 2013. يتم أو يتبين من خلال هذا الجدول أن العدد الكلي للأغشية التي تم استخدامها تساوي 8,136 غشاء مقسمة على مرحلتين، وأغلب الأغشية المستخدمة كانت ذات قطر 20 سنتيمتر وطول متر واحد. بعد فترات التشغيل المتتالية تراكمت أعداد هذه الأغشية مع ملاحظة عدم إمكانية استخدامها في عمليات تحلية المياه مرة أخرى، وذلك لأنها فقدت خواصها التشغيلية بسبب ترسب القشور الكيميائية سكيلينج والمواد الغروانية فاولينج على أسطحها. ومن المحتمل أن يكون لتراكم هذه الأغشية عند التخلص منها وهي بهذه الوضعية آثار سلبية على البيئة المحيطة. من ناحية أخرى هناك احتمال أن هذه الأغشية لا تزال تحوي قيمة كامنة إذا تم إعادة استخدامها بشكل مغاير في تطبيقات أخرى. الوضع الحالي للأغشية الإسموزية المستهلكة في محطة تحلية تاجورة يتم رمي هذه الأغشية في مكب النفايات، وبسبب بعض الإجراءات البيروقراطية أحيانا وبسبب اعتبارات اجتماعية وصناعية وبيئية أخرى، فإن عملية التخلص من الأغشية القديمة ورميها في مكب النفايات قد يستغرق وقت طويل. عندما تصل الأغشية إلى نهاية الفترة المخصصة لاستخدامها الموصي بها من قبل الجهة المصنعة، فإن قسم مراقبة الجودة في محطة التحلية يقوم باتخاذ الإجراء المناسب لعمل التحاليل اللازمة لجودة المياه المنتجة. فإذا كانت النتائج لا تتوافق مع المواصفات القياسية الليبية للشرب، فإن الإدارة العامة للمحطة تتخذ القرار بإزالة الأغشية واستبدالها بأخرى جديدة. بالنسبة للشكل الموضح الآن هو عبارة عن الحاويات التي يتم وضع فيها أو تخزين فيها الأغشية التي لا يتم استخدامها. هذا هو بصفة مؤقتة طبعا إلى أن يتم رميها في صورتها النهائية إلى مكب النفايات، بحيث أن ما فيش إعادة استخدام في الوقت الحالي لهذه الأغشية. ولهذا السبب طبعا أتت فكرة هذه الدراسة. الجزء المعملي يتضمن الجزء المعملي في هذه الدراسة إجراء بعض التحاليل الكيميائية لتحديد التركيبة الكيميائية والثباتية الحرارية للأجزاء الرئيسية للغشاء، حيث تم فصل مكونات الغشاء القديم المراد اختباره وتحليله عن بعضهم البعض وتقطيعهم إلى قطع صغيرة كما هي موضحة في الشكل رقم 2. مكونات الغشاء الموضحة في هذا الشكل تم تحليلها كيميائيا بواسطة جهاز مطياف تحويل فوريه اللي هو FTIR، وتم تحليلها حراريا ايضا بواسطه جهاز التحليل الحراري الوزني TGA. زي ما نشوفوا الشكل الثاني هو عباره عن هذه مكونات الغشاء الرئيسيه طبعا بعد ان تم تقطيعها الى قطع صغيره بحيث يسهل تحليلها الكيميائي والحراري. بعض النتائج والمناقشه. اولا الاحتراق والكربنه. يستعمل مصطلح الاستقرارية الحرارية غالباً للإشارة إلى التغييرات التي تحدث في إحدى الصفات الفيزيائية أو أكثر، والتي تعتمد على درجة الحرارة والزمن. في هذه الحالة يستخدم جهاز TGA التحليل الوزني لتوصيف الخواص الفيزيائية والكيميائية للمواد ومراقبة التغيرات التي تطرأ عليها. وتعتمد هذه الطريقة على قياس مقدار النقص أو الزيادة في وزن المادة نتيجة التسخين، ويسجل التغيير في كتلة العينة بدلالة درجة الحرارة أو الزمن، والمنحنى الناتج يسمى بالمنحنى الحراري. الشكل رقم 3 يوضح نتائج التحليل الحراري الوزني لعدد 6 مكونات الآن في ذكرها في الصورة السابقة، وهي مكونات مختلفة للغشاء. من خلال المنحنى المبين في الشكل رقم 3 يتبين لنا أن العينة رقم 2 اللي هي المواد اللاصقة هي أقل عينة مستقرة حراريا، حيث نلاحظ تحليل كامل للعينة عند درجة حرارة 480 درجة مئوية، بينما العينة رقم 5 اللي هو الفيد سبيسر فهي ثاني أقل عينة مستقرة حراريا وتحللت بالكامل عند درجة 520 درجة مئوية، متبوعة بالعينة رقم 4 اللي هو البرميات سبيسر، والعينة رقم 6 اللي هو انبوب التصريف الرئيسي برميات تيوب. إضافة إلى ما سبق، ومن خلال المنحنى يتبين أن بقية العينات بما فيها العينة رقم 1 الأوتر كيسنج أو الغلاف الخارجي، والعينة رقم 3 لوح الغشاء تعد الأكثر ثباتا واستقرارا حراريا. قرابة 67% من البقايا الغير عضوية للغلاف الخارجي الأوتر كيسنج الذي يتكون أساسا من الألياف الزجاجية لم تتحلل حتى بعد انتهاء عملية الاحتراق، وبالتالي فإن الغلاف الخارجي هو أكثر مكون من مكونات الغشاء المستقرة حراريا. بناء على التحليل الوزني نستطيع القول أن مكونات الغشاء التي تم تحليلها مناسبة لعملية الاحتراق وبالتالي تحويلها إلى طاقة باستثناء الغلاف الخارجي. الجزء الثاني من الجزء المعملي التحليل الكيميائي، انطلاقا من المبدأ الذي يقول أن البوليميرات يمكن إعادة تدويرها كيميائيا وإعادة استخدامها بشكل لا متناهٍ، تأتي أهمية التحليل الكيميائي لعناصر الغشاء لمعرفة مكوناته البوليميرية الرئيسية. بناء على ذلك من الممكن جدا اقتراح المزيد من خيارات إعادة التدوير لكل مكون من مكونات الغشاء. في هذه الدراسة تم اعتماد تقنية التحليل الطيفي FTIR لإجراء التحاليل الكيميائية. لا أقول بأن هذه هي قد تكون هي الطريقة أو التحليل المثالي لتحليل التركيبة الكيميائية، ولكن كانت هي المتوفرة في معامل المركز الليبي للتحاليل الكيميائية. أظهرت النتائج المتحصل عليها من جهاز FTIR أن الفيد سبيسر أو شبكة تجميع مياه التغذية يتكون أساساً من البوليبروبيلين، وأن البرميات سبيسر يتكون من البولي إستر، بينما البرميات تيوب والإند كابس تتكون من مواد غير متبلورة، في حين أن الغلاف الخارجي الأوتر كيسنج يتكون أساساً من الألياف الزجاجية. خيارات إعادة الاستخدام والتدوير. فيما يتعلق بالاقتراحات البديلة لإعادة استخدام مكونات أغشية التناضح العكسي القديمة أو المستهلكة، نقترح ما يأتي: أنبوب التصريف الرئيسي برمية تيوب، فإن خيار إعادة استخدامه هو توصيل عدد من هذه الأنابيب واستخدامها في الري كما هو مبين في الشكل رقم 4. بالنسبة لشبك تجميع مياه المنتج وشبك تجميع مياه التغذية فإن خيار الاستخدام في بعض التطبيقات المنزلية والزراعية. شبك تجميع مياه المنتج استخدامه كشبكات حماية على النوافذ لمنع البعوض والحشرات من دخول المنزل كما هو مبين في الشكل رقم 5.
شيل 3 دقائق.
تمام إن شاء الله. يعتبر شبكة تجميع مياه التغذية من المركبات البلاستيكية المتجانسة، لذلك من الممكن إعادة تدويرها ميكانيكياً وإعادة استخدامها كمواد خام لإنتاج مواد جديدة، وهذا الاقتراح يتوافق مع توصيات في دراسات سابقة. يمكن إجراء عملية الطحن الميكانيكي لبعض أجزاء ومكونات الأغشية القديمة مثل الغلاف الخارجي المصنوع أساساً من الألياف الزجاجية. خلال عملية الطحن الميكانيكي يتم تحويل الغلاف الخارجي إلى قطع صغيرة وأحياناً مسحوق ناعم، وبالتالي إعادة استخدامها كحشوات في الخرسانات مثلاً، وهو يتوافق أيضاً مع مخرجات دراسات سابقة. بالنسبة لأجزاء الغشاء التي تتكون من مكونات بلاستيكية متعددة ومختلفة مثل الممبرين شيت، فيمكن إعادة استخدامها كمصدر للطاقة. الاستنتاجات وبعض التوصيات. تعتبر هذه الدراسة هي الأولى محلياً التي تهتم بإعادة استخدام الأغشية المستهلكة من محطة تحلية المياه في تاجورة. عندنا الشريحة الأخيرة أو
This is unit conclusions.
conclusion. نعم. زي ما حكيت تعتبر هذه الدراسة هي الأولى تقريبا من نوعها في دراسة أو إعادة استخدام الأغشية المستهلكة في محطات التحلية على الساحل الليبي. النقطة الثانية، هذه الدراسة تقدم عرض تفصيلي للأغشية القديمة التي استخدمت في محطة تحلية تاجور العاملة بتقنية التناضح العكسي. أيضا عرضت تاريخ منذ استخدامها في فترات منذ فترة الإنشاء وحتى مدة الدراسة. بناء على المخرجات، فإن مخرجات هذه الدراسة وبعض الدراسات الأخرى ذات العلاقة، فإن على الجهات الحكومية في ليبيا وبعض الشركات الخاصة أيضا القطاع الخاص عليهم أن يقدموا جهود لإيجاد حلول أو اقتراحات مجدية للمستهلكين حتى أثناء التعاقد مع الشركات أو الجهات التي تزود بالأغشية الإسموزية. فيجب أن تكون هذه النقاط منصوصة وواضحة في العقود الجديدة بحيث أن يتم تحديد خيارات إعادة الاستخدام مثلا، إعادة فترة الانتهاء وما شابه. الجهات المعنية أيضا وصناع القرار عليهم اتخاذ المبادرات التي من شأنها أن تحافظ على البيئة بحيث أن يتم الاستثمار في تقنيات تحلية المياه الصديقة للبيئة. شكرا جزيلا لكم ومشكور على حسن الاستماع.
شكرا باشمهندس. شكرا. Can we take one question, Dr. Salim?
Thank you for your presentation, but I have one question related to the asbestos contained in these membranes. So, and this is a serious problem for health reasons, essentially for the employees.
Could you just please raise your voice?
Okay, so my question is related to the asbestos contained in these membranes. You have not mentioned this, and this is a serious problem, a serious health problem for employees in these desalination plants and when we are recycling them. Thanks.
Yes, you mean the ABS. Yes, you are right. It's a very complicated material, but as I mentioned, this is our first piece of paper regarding this reuse of membranes. So we are still suggesting some other papers or maybe studies to focus more specifically in this components.
It's okay. I think we'll go to the next paper. Thank you, Mr. Bashir, for your presentation.
Thank you very much.
Thank you very much. Our last speaker in this session is Dr. Yusuf Al-Wazan. Are you with us, Dr. Yusuf?
Yes, علي. السلام عليكم. مساكم الله بالخير ومنور اخوي علي.
Thank you very much, Dr. Yusuf. Dr. Yusuf is a BSc and MSc mechanical engineer. He got his later PhD in mechanical engineering from University of London. He works for KISR, the Kuwait Institute for Scientific Research. He started as a researcher. Now he's a division director of science and technology at the Water Research Center in KISR. Dr. Yusuf, the floor is yours.
Yeah, thank you. Is the screen clear?
Yes, yes. Yeah.
You can see
Yes.
that.
Go ahead.
Okay.
Go ahead, please.
Good afternoon, everyone. Of course, today I'm going to talk about assessment of freeze melting technology for brine concentration. It's not switching. Okay. I will go over the items shown in the first slide. Start with introduction, ending up with conclusions and recommendations. Of course, talking about seawater desalination in Kuwait, we are fully dependent in Kuwait on seawater desalination. And we have installed 3 different technologies: multi-stage flash, reverse osmosis, and multi-effect distillation with different capacities. Of course, in these desalination plants, as you know, we get product, and at the end we get reject with concentrated brine that will be forwarded back to the sea, harming the environment and the marine life. And if this is only Kuwait, look at the full picture for the whole Arabian Gulf. Look at the number of the desalination plants with different technologies, and imagine how much brine is going back to the sea. And this is now and earlier and now, and of course in the future it will be increased. Seawater desalination challenges, of course, corrosion, scaling, fouling problems, and many others. But the thing that I'm going to concentrate on really in my paper is the brine challenges, with large volumes being dumped back to the sea, high TDS and degree of hardness, chemical additives, temperature higher than feed water. Brine contains undesirably higher suspended substances compared to feed water. Of course, the last 2 is regarding to the thermal desalination plants. And this figure only shows the major components of seawater and RO brines. And just for an example, look at the TDS from 48,116 to 78,450. So that's just to give you an example. Of course, to date, intensive research on innovative seawater desalination technologies is carried out by scientists all over the globe to determine the most feasible brine disposal process. Of course, at KISR here, we believe that freeze melting technology could be feasible for such an application. Of course, the freeze melting technology is based, if you see at the far left, the principle of FM. I'll go back to the slide. We can see that it's based on crystallization, applying cooling, then crystallization. Then when full crystallization is being formed, then we separate the brine from the crystals, then we do the melting. And the middle, the layer crystallization, you can see as the cooling process go ahead, then the ice crystals will be formed, rejecting the more concentrate. If we go to the right figure that shows the temperature time profile versus the heat transfer medium temperature, here in this you can see the full picture of the full cycle that I've just explained. And here we usually at the beginning of each experiment will set up the time required and the temperature required for moving from crystallization up to the melting process. Of course, you can see between T3 and T4 there is something called sweating. As in the middle figure, you can see that as the ice crystals gets formed, then the separation process or the reject is moved away from the crystals. But if you look, there are within the crystals there are some brine droplets that are trapped within the crystals. Doing the sweating process with increasing the temperature with the help of gravity, these droplets will be removed away from the crystal to get much better quality of the our product. Of course, freeze melting has advantages like low energy requirement, low biological fouling, etc. FM has also advantages over conventional freeze desalination in terms of handling and separating ice slurries, as well as easily control crystal growth rates and so on. Moving to the study objectives, the main objective is to assess the viability of a static and 3 dynamic freeze melting processes to concentrate brines, compare experimental data, and propose simple conceptual design of pilot scale system for desalting and concentrating brines. Here in the experimental result, when I go and discuss the experimental results, I'm going to concentrate on the salt rejection and the water recovery for the whole different types of processes. And then I'm going to select certain values for salt rejection and water recovery to utilize these values for my calculation for the integrated system between the RO and the one of the freeze melting technologies that will be selected in a while. And this slide shows the physical and chemical analysis of the tested feed, this table, and then the main thing that I'm interested showing the schematic experimental setup. See if you can see number 1, this is the controller, heating and cooling bed controller. Here where I'll set up the required time and temperatures for the whole cycle of the process, starting from the crystallization up to the melting process. And I just forgot to mention that during our experiments, our experiment did not cover the sweating that process that I've talked about. And then, of course, this will the rest of the figure here will show the different parts of the experimental setup, the different types of freeze melting technologies, static, air pump, ultrasonic device, static crystallizer. And here in this slide, you can see the different, types of dynamic and static freeze melting crystallization systems. This slide shows how the preparation or how the full cycle goes, starting from the preparation of the sample, putting it into the jacketed beaker, and then applying the required time and cooling and heating temperatures to go to get the reject and to get the product water. Here we have an overview of the logic of the experimental envelope. And here we'll start showing the results with the static freeze crystallization process. As I said, I'm going to concentrate on the salt rejection and the water recovery, which is versus the cooling rate. If we can see with regard to salt rejection, if we can see the at high cooling rate, okay, which is closer to the zero value, we can see salt rejection above 23.5%, whereas at the same point, the water recovery is lower than 25. And then as we drop the cooling rate, then we can see a drop in the salt rejection and increase in the water recovery, because the quality of the water, as I said, the salt rejection is being dropped as the cooling rate is being dropped, is due to the droplets that is being trapped in the freezing crystallization or in the ice crystal. So these values, of course, we are looking at the values close to the zero to reduce the power consumption for the whole experiment. So these values were not suitable for our integrated value calculations. Moving to the ultrasonic process, again, the salt rejection and cooling rate, the values that we've obtained are low. And even if we drop the cooling rate, again, the salt rejection and water recovery are not suitable for our calculation. Of course, we started the cooling rate at amplitude of 20, and we moved to 40 and 60, but again, it's the same situation. We did not find the suitable salt rejection and water recovery for our calculation. Moving to the bubbling process, again, in this way, again, the closer to the zero is still, even though the salt rejection is a bit above 30%, we see the water recovery is too low. Airflow rate, of course, we've experimented 10 liter per meter. The values were not okay. At 20 liter, the values still are okay, not okay, and 30 liter are not okay as well. Moving to the mechanically steered system, we moved right to the point. We started by using a steer rate of 200 RPM and 400 RPM and 600 RPMs. But the best values that we've obtained at the steer rate of 400 RPM, here we can see that we obtained closer to the cooling, closer to the zero cooling rate, salt rejection of 30%. At the same point, we obtained a recovery for 41 in the range of 41.1%. So these values are suitable for our calculations for the conceptual design. General observation, of course, I will start with the, according to optimal operating conditions, the tested freeze melting influenced by the steering process was capable of reducing the salinity values of feed with salt concentration of 70,000 ppm down to an average of 49,690, which is suitable to be utilized as feed to the RO technology. Of course, average water recovery, as I said, 41.1. This is the conceptual design of the pilot scale system.
Can you just
of course, This is our calculation. We use the RO Kadma bottling plant exists at the Doha research plant. Of course, the feed here is 27.3. The brine coming out of it is 19.3 meter cubic per hour with concentration of 7%. This is used as a feed for the freeze crystallization agitated by stirrer, and the results or the product will come as 8.1 meter cubic. This 8.1 meter cubic will be used to be added to the main feed for the first stage for the RO, reducing the amount of water obtained from the main source. At the same time, we get reduced the residue volume to 11.2, from 19.3 to 11.2 with concentration of 8.5. Now, maybe someone will have a question. Okay, I already reduced the quality or the volume of the brine, but what about the concentration? I increased the concentration. Well, in here, yes, I'm not going to throw this concentration back to the sea. I have other plans for it. We have the zero liquid discharge process and the mineral extraction. We do need in these two processes we do need a higher concentration to achieve the zero liquid discharge and the mineral extractions. At the table, we can see the Kadma RO plant that produces 191 brine ton per year, starting from 239 ton per year as feed. And the brine will be reduced as 98.11 ton per year. And the feed also will be reduced to 168.19 in the integrated system. So these are the advantages we are obtaining. In conclusions, I've already discussed the feasibility of the freeze melting technology using a stirred agitation system, which gives a clear indication that the proposed FM process could be feasible process for concentrating RO brines in order to minimize the volume of the waste streams of RO desalination plants, and more specifically, if it's inland desalination plants. The recommendations is increasing the crystallizer capacity to a suggested range of 50 to 100 liters, taking into consideration the fact that the investigated agitation system might be changed to higher agitation rates corresponding to the crystallizer capacity. Multi-stage freeze melting and post-treatment process should be further investigated and assessed. A jacketed tube with a discharge option at the bottom will be very easy to control for future studies. Multi-stage freeze melting and post-treatment process should be subjected to further detailed technical economics analysis and investigation for future applications. And this is the end of my presentation, and thank you all for listening to me. Thank you, colleague Ali.
Thank you.
And thank you for all the audience that are following the presentation.
Thank you, Dr. Yusuf. Thank you very much. I'll just allow one question, please, if there is anybody for Dr. Yusuf, all the other speakers, because they are hammering me and they're calling me to adjourn the meeting here. So please, if there is any...
If I can, please raise the voice, because it's very hard to...
Yeah, I know. I'm just trying to get you a question, if there is anything.
Yes. Okay, but I mean...
Okay. Thanks, Dr. Yusuf. Thank you very much for your presentation, and hope to see you soon in person, please. Do you hear me?
Yes. Ali?
No, I'm trying to say that thank you very much for your presentation.
Thank you, Ali. It's hard. I have very hard, trying to hear you, but I think that you are saying thank you and I'll see you later. Ali, I cannot hear anything.
Yaqub, thank you very much. I had to conclude the session.
Okay.
Thank you very much. Magasart.
Thank you, Ali. Thank you very much.
Thank you.
الله يخليك يحفظك.
الله يخليك إن شاء الله. Thank you. سلام على الجماعة.
You are welcome. I will. Thank you.
Thank you. Dr. Yusuf, are you with us still? Dr. Tamer?
Yes, Doctor.
Yes, Ali. We are looking for, we are looking for a recommendation from you, please. If you can just email it to me.
Okay, for the whole?
Yeah, for one recommendation. If you have one recommendation based on what you have heard in this session, if you can just send me by email, please.
Okay, regarding my presentation.
Yes, please. Yes.
Regarding my presentation.
Dr. Tamer and Robin, please.
Inshallah.
Robin, are you still there?
Yes, I'm still here. Yeah.
Okay. Robin, please, are we expecting?
Sorry, what is that? Expecting?
A recommendation for how to go forward.
Yeah, I will send that to you by email. No problem.
Thank you very much, everybody. Thank you for joining.
Yes, likewise. Thank you for having us.
Thank you.
شكرا جزيلا. السلام عليكم.
مرحبا عادل.
هلا
مشكور حبيبي، انت كنت هناك بغيناك تجي هني. زين
انا كنت في جلسه ثانيه ما خلصت.
ادري الحين انت راح تقدم هني ان شاء الله. ها
اوكي
يلا بس ننتظر بعد دقيقتين واحنا بنبتدي بعد شوي.
هذا الاولاني مع سيد.
لا خليك هني، هذا انت خليك معنا هني، لا تروح مع ذاك.
اوكي
انت الحين في الاندستريال سيشن، هذيك كانت في الويست ووتر.
ايه
اوكي مشكور حبيبي.
افتح لي شو اسمه الاكسس حق الشير.
اكسس حق شيرنج. اعتقد عندك شيك.
بعد ما فتح.
اوكي مكتوب اونلي هوست. سوي شيرنج عادل نتاكد.
اوكي
يا جرب شيرنج على الاقل نتاكد. اوكي شغال. اوكي اكو شغال. اوكي فانت بدورك عقب سيد.
اوكي
سيد احمد بيكون اول قبلك بعدين انت وراه. اوكي
ماشي اوكي
ستوب شيرنج بنبتدي السيشن بعد شوي.
اوكي
مشكور حبيبي.
وياك.
بس احنا
عليكم ورحمة الله وبركاته. وأسعد الله مساكم بكل خير. Welcome to session 3, Industrial Water Management. I am Engineer Arif Al-Kalali, Senior Consultant at NIWA. We have potentially 3 speakers. We will start with Sayyid Ahmed. Sayyid Ahmed is from Process and Control Systems Department, Saudi Aramco, Bahrain, Kingdom of Saudi Arabia. Sayyid, the floor is yours. You have 15 minutes.
Yeah. All right. Assalamu alaikum. Good afternoon, everyone. My name is Sayyid Ahmed, and I will be talking about produced water reuse towards circularity. This is basically a case study about how we're reusing water in our oil facilities. So I'm the main author, and the co-author is my supervisor, Khalid Yusuf. I'm from Tehran. Okay. In terms of the presentation flow, I'm going to keep it very simple. I'm going to talk about what the water is. I'll talk about produced water reuse, technologies that we've used, and I'll talk about 2 case studies that we've done at Aramco for different salinities of water. And finally, finish off with water circularity, what we see could help our circular economy objectives, and finally a path. I'm not going to go much into the oil and gas supply chain. It's a pretty massive one, spread across at least Aramco and even other companies as well. The only area I'm going to focus is we've basically taken what we call as a heart of a process gas oil separation plants. There's obviously opportunity for water reuse. If we're able to do it with gas oil separation plants, we're able to do it pretty much across the rest of our supply chain. This is the most challenging stream that we process in the company. We process pretty much 5 grades of crude, different plants spread across the kingdom, and we meet different quality specifications. Of course, one is water concentration. Gas oil separation plants, very simple. We just take oil, gas, and water. We separate it into 3 phases. So the blue line that you see at the bottom is what we call as produced water. This is what comes as a consequence of separation between the oil, gas, and water. So this is the stream that we'll be talking mostly about, and we collect it across different parts of our plant. In terms of quality, now we're all water engineers here mostly, so I'm a produced water guy. In terms of quality, if you look at it, our seawater obviously is in the range of around 45 to 55, depending on how you sample it. We have aquifers, of course, in Saudi Arabia between 6,000 and 54,000. But our water, of course, is quite high. It starts from 100,000 all the way to 250,000. The only thing I want you guys to know is the temperature. Our feed stream water that comes in is pretty hot. So this is an opportunity that we are hopefully trying to catch up on and try to reuse and treat our water. In terms of the concept that we've done basically for produced water treatment is we've taken the water, we've looked at it in 2 terms of streams. Obviously, this is a small schematic of small portion of our plant. And obviously, we produce like 30 million barrels, 12 million barrels of crude technically. And we use a lot of water for that. So one stream that we get is obviously the water that we're sending to injection wells. So I call this high salinity. It has a TDS around about 98,000. The desalted effluent water is around 15 to 20,000, and even 8,000 depending on. So these are the 2 streams that we've looked at. We've looked at technology options, and this is basically what we wanted to do was try to look at ways in reusing this water so that the water that we use for washing the crude, as we call it in the industry, or desalting, right now it's from the non-potable groundwater. We basically want to completely eliminate this. So that was the main objective and the driver. So we looked at 2 main salinity streams across the organization. So in terms of technology roadmap, we've obviously followed the standard process globally that we have. We're basically looking at, we're setting our benchmark around 100,000 TDS, oil and water concentration between 50 to 100 milligram per liter. H2S obviously around 100. Most of our water is sour water. The technology that we've at least looked at internal within the company and also across the thing is, of course, for us, we're looking at evaporators as a primary. Secondary would be membranes, ionization membranes, and engineered membranes. These are the technology that we're basically looking for commercial rollout across our facilities. And of course, the quality that we're targeting is low salinity water. We're talking about 800 to 1,000, 1,500. And of course, any thermal process and evaporation process will basically need very little amount of oil into it. So these are the technology commercial that we're looking at. In terms of a process stream, of course, like people talked about in the conference, pre-treatment is a big expense or a big cost in this case. And obviously, we're looking at technologies to deal with. This is something that we do pretty well in the oil and gas industry, doing the pre-treatment of water, removing it down to the quality that we require. So obviously, de-oiling, H2S removal, and probably a stripping column, maybe a backbed as well to remove the DOCs, depending on the downstream technology that we're using. So membranes and evaporation seems to be the best option. Obviously, we're looking for plants that work 24/7 and not a batch process. And we've set our recovery factors around about 70% recovery factor. That's our basic guidance that we're using to look at technologies across the market. The first case study that we did was obviously at a site in near Grace. We basically took the desalted effluent water, we sent it to a combination of ceramic membranes and reverse osmosis membranes. This was done over a period of 3 to 4 months. We basically used ceramic membranes to de-oil or produce water, and then we sent it to conventional RO membranes for high temperature resistant ones. We were able to get a pretty good recovery factor around about 70%. DDs at around about 800 to 1,000, and this was a feed. This was around 2,800, and the brine, obviously getting rid of the brine was a bit of a headache. And basically, we tried to send to a pressure pond and even to a landfill as well. Obviously, this generates technologies. Looking at technologies to get rid of brine is another issue that we have to deal with. And there was some pretty exciting example about flash freezing that the other gentleman had talked about earlier as well. This is again just the process schematic of that water stream getting in, getting out. I talked about ceramic membranes being utilized here. We had a stripping column, we had an organic scavenging unit. Of course, this added quite a bit of substantial cost to our process itself, and we could use conventional RO membrane processes to get that. This is basically how a unit looked like. Very simple. With ceramic membranes in series. This was a free water quality, and this was a product. RO membrane tester stripper. Of course, all these details will be in the paper that will be published by I think the society already. So all the technical details, the number exact, you see on the papers. The second case study that we had was related to looking at the more challenging stream, higher salinity water. So WASEP, or what we call as a water oil separate. This is the actual produced water that we see in our oil and gas operations. So around about 100,000 is what we took as a benchmark. We again looked at different technologies. And one of the first of many, this is the first one that we tested out, mechanical vapor compression. I'll talk a little bit about the technology as well and what we were able to achieve. So this was the second pilot that we did. In terms of the, sorry, my bad, pardon me. In terms of the process, obviously we're looking at removing the H2S. Of course, this particular technology we were told is very resistant to oil in the feeds and contaminants and stuff. We went by their word and we went through the process. However, we faced a lot of challenges in the heat exchanger system. I'll talk a little bit about it. So we did basic sodium hydroxide stripping and stuff, so on and so forth. We sent it to a column, what we call as a low atmospheric pressure flash column. And then we have water basically going into steam where we heat it up and then send it to a loop. And then you collect the vapors basically eventually as a distillate. Very energy intensive process. Lots of issues in heat integration. If you don't get the heat integration right, we end up in a lot of problems. Again, what do we do with the blow down of the concentrate as well? That's another challenge. So produced water is not easy. Again, it has various feed requirements. We obviously don't have a fixed 96,000. We have anywhere between a good day between 50,000 to 60 or even 100, 110. So we have the technologies. Most of the technologies are not used to variable feed. So constant optimization of this process, the heat integration is very important. And that's where a lot of the suppliers are kind of failing in it. But of course, this technology obviously is a very energy intensive as well. So this was the second test that we did. In terms of this is how the equipment looks like. It is a simple flash column, a couple of distillation compressor pumps. This was our feed sample, this was our concentrate, and this was our product. So as you can see, it's relatively clear. The oil concentrate obviously is a headache to be removed off and disposed of, and the product is this. This technology obviously won the 2020 Global Water Awards. It was highlighted in the media because this had a potential to use water, produced water, which is generally considered in the oil and gas industry as a waste, but obviously move for much higher salinity water. Yeah, that's kind of like what I have. Apart from that, we're also doing another pilot test that we're running on a similar mechanical vapor thermal technology, where we're pushing it to boundary further to do maybe zero liquid discharge as well. In terms of water circularity, obviously, this is a thing that we generally take water, we process it, we dispose of our water. We basically want to look at means of looking at this in the oil and gas industry, where I'm from, reducing water consumption, recycling, and reuse. This is what I call as the 3 R's of water circularity. Sorry, this slide is a little messed up. But in general, we just take, make, dispose, pardon me on that, we dispose of in injection wells. What we're hoping to do eventually is take technologies, look for other technologies out there, terminal, non-terminal, a combination of them. Generate, of course, water not only for our industrial reuses, but we also want to be able to provide for other industrial applications related to water stress. Clean water, obviously, and also for other allied products that may require water injection. So we want to create a 3R loop, reduce, recycle, and reuse in terms of water. That's what we are targeting internally. We're hoping to meet that. Apart from meeting our carbon requirements, we're also trying to be circular in terms of water as well. Yeah, what are some of the challenges? Of course, the high salinity, it's a big issue. Getting rid of that disposal, what do we do with it? We're trying to look at ways of using the brines for other alternative opportunities, but that's something that we're currently exploring on. Technology, of course, is also maturing, but mostly are thermal based, and I see membranes are slowly catching up to that phase. Energy requirements, yes, for the thermal, it is quite energy intensive. It was around about 39 to 40 per meter cube that we had used kilowatt per hour, quite energy intensive. Finally, policy, like we definitely need more policy to push for other water sources. Apart from the groundwater, we also need to look at produced water as a strategic source and try to supply as well. So that policy changes will definitely help as well in terms of that. And with that, I conclude my presentation. I would like to thank colleagues across different organizations. None of this work is possible without extensive collaboration across the company. And that's it. That's it from me. Questions? Thank you.
Thank you very much, Saeed, for an interesting presentation. Now the floor is open for your questions.
Good.
Thank you, Mr. Said, for this esteemed presentation. My inquiry regarding the case study 2 about the high salinity, about 100 grams per cubic meter. So is it the location of the oil field in this area, or is it the depth very deep? This is why the salinity become more intensive.
Produced water in general is around about, depending on the field as well, we have multiple fields. So it ranges in the company from 50,000 to almost 200,000, depending on which reservoir or which oil field we extracted. So it's not something that we control. It comes with the reservoir itself. It's nothing to do with the depth. From which field are we extracting, for example?
The nature of the reservoir.
Nature of the reservoir, in simple words, yes.
Which area?
We did Gawar. Gawar is a big field. We have multiple. Average is around about 100. I wouldn't mention specifically the field, but I can say it's Gawar. It's around about 100, 110,000. Right. Any more questions? Cool. Thank you.
I have a few.
Sure.
Thank you. Actually, an interesting question here, and to my knowledge, by the way, I am a 30-year veteran of Aramco.
Mashallah.
So, and I'm aware of that even in the Hawar itself, within the Arab Deep, you have a high variation in salinity whether from west to east and from north to south. And there are areas where the salinity goes way down. Okay. But I understand that what you are getting is actually a blend. It is not from one area or something like that. So this is one thing. The other thing is that the oil field in the central area, actually, I think some of them has much lower salinity. And to answer your question, one of the problems of oil fields, why the meteoric water does not get into them and reduce the salinity is because the meteoric water cannot get through the oil field. The oil phase blocks the flow, okay, and thus no flushing when the oil has been placed. Okay, it's hydrogeological process. My question is, for the high salinity, that you get, or what you call the disposal, is there a chance to invest in the minerals that you get from groundwater from these areas?
Okay, it's an ongoing collaboration. All I can say is we have characterized all our waters, and there is some potential. I will not say what numbers it is, but there is potential, and that's something that we are looking at as well, and there are some active studies on it. So yeah, there is substantial amounts for commercialization. That's all I can say. But provided we do brine, I mean, if we do this technology, part of the disposal of the brine would be the extraction of certain minerals from it. So it's also a case study.
And the reason why you cannot say is because you haven't reached the conclusion, or it's a proprietary?
We haven't published anything officially about it. As you know, the process, we have to get the approval to talk about this technology. Yeah, that's it.
But beyond the depth of this one, or what?
I think there are published. I'm still committed to the confidentiality but there are published reports, majorly in the petroleum engineering publications, and you can see there is one in Geo Arabia that has been published, and it is by Stigner. The paper is by Stigner, and it is there.
All right, thank you.
Any other questions? Any other questions? Okay, thank you, Sayed. Thank you. Our next speaker is Dr. Adil Al-Haddad. He is a research scientist and program manager for wastewater treatment and reclamation technologies program in the Water Research Center at Kuwait Institute for Scientific Research. He obtained his PhD in wastewater treatment from the University of Strathclyde in Glasgow, UK. Dr. Adil Al-Haddad has participated in several surface water and groundwater, domestic and industrial wastewater projects. He has more than 20 years experience in the field of geology, chemistry, microbiology, water contamination, and treatment technologies. He has several papers published in refereed journals and international conferences related to water resources management. Dr. Adil, the floor is yours. Dr. Adil? Dr. Adil, the floor is yours. If you can unmute, please. Dr. Adil, we cannot hear anything. If you can unmute, please.
You observe the screen?
Yes, now I can hear you well.
You show the screen or still? The screen is clear?
Yeah, can you share the screen, please? Can you share the screen?
Can you put the share, please? Access for share.
It is granted.
Mr. Araf, you observed the screen or still?
Still, we can't see your share screen.
I'll try again. Yes. دكتور وياك الشير الحين؟
I'll let my technician speak with you.
دكتور
هلا
من فضلك اعمل شير سكرين.
انا خليك شوف، انا بطلع اول شيء بطلع شوي بسكر المحاضره.
افتح المحاضره بعد كده اعمل شير سكرين.
المحاضره موجوده عندي بس شير سكرين
مع حضرتك الصلاحيه.
يطلع لي شير.
اضغط الشير سكرين اللي في النص الزوم.
بس الشير سكرين ما قاعد يطلع وياي. تحت ما قاعد يطلع وياي. اطلع مره ثانيه اجرب، اطلع مره ثانيه واجرب وياك. اوكي لحظه شوي بس لحظه. خلينا نشوف هذا المحاضره. ايميل عماد الشير ما قاعد يفتح وياي.
Apologize to all of you for this technical problem.
ما قاعد يطلع وياي. اخ عماد تقدر تحط الفيديو ريكوردينج اذا ما قاعد يفتح وياي؟
لحظة شوي.
دكتور اضغط شير سكرين اللي باللون الاخضر.
الشير ما قاعد يطلع وياي، علامة الشير ما قاعد يظهر وياي.
حضرتك فاتح المحاضرة البرزنتيشن على الفول سكرين؟
البرزنتيشن مفتوح.
على الفول سكرين ولا
لا بس على عادي فاتحه.
علامة زوم عند حضرتك مربع صغير على اليمين.
ما اسمعك.
في علامة الزوم عند حضرتك مربع بتاع الزوم، مربع صغير.
علامة
زوم فيها سهم صغير أخضر على اليمين.
المكتوب شير اللي عليه شير.
أيوه.
اوكي.
اختار بقى، اختار البرزنتيشن، مربع أولي مربع على اليسار فوق.
أنا اوريدي مختار البرزنتيشن.
دبل كليك عليها هيفتح على طول. لما
بتضغط مفتوح عندك من الحين؟
لا مش ظاهرة يا دكتور. طب اعمل شير من السكرين من عندي حضرتك
اوكي. اوكي بالنسبه لك؟
اذا حضرتك في رساله ظهرت عند حضرتك، خد ريكويست، اضغط على ريكويست. تمام. اتفضل دكتور، المحاضره مع حضرتك بقى، قلب من عندك.
اتفضل. Just tell us next when you need us to go to the next slide.
ظهر البرزنتيشن قدام حضرتك؟
اي نعم.
تقدر تحرك من عندك، اتفضل. جو نكست دكتور.
ثواني بس. انا اخر شيء برجع كذا شو نسيت.
اضغط ابروفال على المسج اللي انا ارسلتها لحضرتك.
اوكي الان
اضغط ابروفال على المسج اللي انا ارسلتها لحضرتك. كنترول. ايوه تمام.
اوكي.
اتفضل حضرتك بقى، جو سلايد.
واضح عندك الحين؟
واضح. اتفضل حضرتك. نكست سلايد اتفضل.
Okay. Sorry for the late for showing the presentation. My presentation will be focused about establishment of database for total petroleum hydrocarbon in industrial wastewater generated at Sabhan area in Kuwait. I'm presenting this paper on behalf of me and for a group of researchers from Water Research Center at Kishar. I'll try to give a brief about the problem of the industrial wastewater in Kuwait, the main objective of the study, along with the methodology and the results which we obtained. Finally, the conclusion, the recommendation which was suggested for the future work. Kuwait is a modern country, depends most of the needs of domestic, commercial, and industrial wastewater on the water of desalination of desalination water plants that we have here in Kuwait. Kuwait needs an integrated water resources management scheme that includes aspects of water conservation and reuse of wherever is possible. The block of such management scheme, which include water supply location, use, after use discharge, recycle potential. This block is missing. In Kuwait, we don't have it. One of the major sectors involved the scheme of industrial for petroleum and non-petroleum water use and wastewater generation, including areas after use, discharge, wastewater quality, and origin, discharge points, location of discharge, and reuse, recycle potential. All these things are missing. A basic and comprehensive database utilizing ArcGIS software in this sector is presently lacking in this country. So, establishing the data and database, especially for the type, the quality, and the quantity of industrial wastewater produced from each factories in Kuwait. This information and the type of a treatment unit, if it is available with the factories, this database is missing. And this study tried to put the first block to establish a database for such industrial wastewater. So the main objective of this study was to determine the quality and quantity of petroleum, non-petroleum industrial wastewater from different sources at Sabhan area in Kuwait over a period of 1 year, as well as developing a database of such characteristics using GIS technique. Within task mobilization, all the equipment which is needed for the field and for the software and for the laboratory analysis were purchased. Also, field survey was carried out, including questionnaire in Arabic and English questionnaire distributed to the owner of the factories. Also, industries in Kuwait are mainly, they are distributed in 3 areas: Kuwait City, Sabhan, and Shu'aiba industry areas. Shu'aiba mostly reflects petroleum wastewater origin, while the Kuwait City and Sabhan represent non-petroleum wastewater origin. This is the location here. You can see the Kuwait City in the north of Kuwait Bay here. In the middle, Sabhan factories here. In the south, Shu'aiba industry area, which is mostly for petroleum wastewater origins. This is type of the questionnaire for that was used during the study. All details of the factory, their location, their owner, their products, how many lines of productions, the sampling point, all this information is recorded in the questionnaire. If there is any treatment units there at the factory, what level of a treatment, what kind of water is produced, for what is reuse option, all these things. And as I told you, the raw material of the water, which is, or the factory which you are producing, all this is included in the survey. So based on the field survey of the targeted industry, the total number of the factories for sampling and associated measurement were determined. So industry wastewater samples were collected from 41 sites, factory distributed as followed: 10 factors from Kuwait City, 14 factors in Sabhan area, 17 factors from Shu'aiba. Field wastewater measurements were carried out for all these sites, including measurement of temperature, pH, electric conductivity, dissolved oxygen, and oxidation reduction potential parameter. The collected samples were analyzed according to the standard method for examination of water and wastewater, American Public Health Association 2017, for determination of physical, chemical, biological, organic, heavy metals, toxicity, microbial, bacteria, viruses, fungi parameters. This is some photos for sample collections, field measurements, some laboratory analysis. So before we start generation of the GIS maps, we develop Excel spreadsheet database for the field data and for the lab data. So we use this ArcGIS software to convert all these Excel database to GIS database, from which a number of GIS maps were produced. Now, the factories which are targeting Sabhan area is around 14 factories here, starting from Al-Yusra company, which is a chicken preservation company. Then comes Petra Food Company, going to Al-Mahjam. Then we have Flour Mill Company, number 4. Then we go to Gulf Pastries. Then we have soft drinks factories, which is Coca-Cola, Pepsi, number 7, United Beverage, Asair, also RC Cola. Cartoon industry, plus we have also Gulf Insulating, 2 factories for Gulf Insulatings. Then we have number 2 is aluminum factory. Then we have detergent factory, number 13, 14. There is code for each sampling location along with the coordinates. So this is the code for the distribution of the factories of Sabhan area. The red one is the Sabhan area here.
دكتور لو سمحت ايه في البرزنتيشن اللي عند حضرتك متابع من البرزنتيشن.
اوكي 1 minute. اوكي
حضرتك شايف البرزنتيشن من عندي؟
يس
تمام كده اوكي؟
اوكي. So this is the locations of sampling for Sabhan area. Now the x-axis is the factories and the y-axis is the water quantity meter cube per week which is produced.
Dr. Adel, if you can please expedite your presentation because we lost some time at the beginning. Okay, thank you.
I'm trying, moving very fast. From the soft drinks, there is 1 million meter cube per week which is produced from the factories. You can see the consumption of fresh water and the wastewater. This is the changes in pH value for wastewater from Sabhan factories. You can see a few factories, they are below the maximum limit set by Kuwait EPA. The others are within the range, the mean values within the range. The conductivity, all these samples represent freshwater factories, except the factories of Basris and the Al-Bahar company, which shows brackish freshwater. The others are freshwater. The oxidation reduction potential, you can see the samples who's above, the readings above 0, which is oxidized, while these areas, mostly they are in negative sign, which shows reduced environments. The dissolved oxygen also, you can see it, which is reflection for ORP. Also, you can see the reduced environment, while these above 2 milligram per liter, which is set by Kuwait EPA, they are shows oxidized environments. Here, regarding the main thing here for total petroleum hydrocarbon, Kuwait EPA set a value of 5 milligram per liter. You can see that all these averages are below 5, so we don't have any problem. With respect to this parameter, we can use this water without any treatment for irrigation regarding total petroleum hydrocarbon. This is the values of the legend of TPH, the minimum values. This is the Subhan area, the location of it. This is the Subhan area magnified here in the red square you have here. Here is the average values for TPH for the Subhan area. You can see according to the color, the concentration. Also, you can see the maximum values for TPH for Subhan area. To conclude, this database, the first step to categorize the quality and quantity of wastewater from the factories of Kuwait. The laboratory results of the TPH indicate that their concentration in the raw wastewater are meeting CAPA irrigation water standards for landscaping and greenery, except maybe a few values for maximum values, which is above 5. The obtained field data suggests that only few industries use on-site wastewater treatment system. Mostly they use it for buffering the pH unit. Okay. Just to recommend, the collection of data should be continue for measuring quantity and quality of industry wastewater for petroleum and non-petroleum origin for longer monitoring period. And the Public Authority for Industry should be continuing doing the update for these database. On-site treatment system should be also installed to treat the industry wastewater from group of industries of similar sources. At the end, I would like to thank KEFAS and KISAR for funding and supporting this study. Also, my thanks expressed goes to all the staff of Water Research Center at KISAR. Thank you.
Thank you very much, Dr. Adil, for this interesting presentation. Unfortunately, we don't have time for questions. We will move to our next speaker. Our next speaker is Dr. Imad Farouk Aboukila. He's an associate professor of soil and water science, College of Agriculture, Damanhur University in Damanhur. He's a postdoctoral scholar at the Department of Crop and Soil Science, Colorado State University, USA. Dr. Imad, the floor is yours.
Dr. Imad.
Assalamu alaikum wa rahmatullahi wa barakatuh. Thanks for your introduction. My name is Imad Aboukila. I am Associate Professor of Soil and Water Science, College of Agriculture, Damanhur University, Egypt. So my talk today will be on the effect of industrial activities on the heavy metal contamination of irrigation water, soil, and plants in Kafr al-Dawar district area at Egypt. Kafr al-Dawar district at Al-Bahira Governorate, Egypt is an agriculture area, but with extensive industrial activities. It contained 4 major industrial companies: the Kestel and the Spinning Egyptian Company, Tinting and the Chemical, Industrial Silk Egyptian, and Al-Beda Dyer companies. These companies have been using the agriculture drainage system to dispose their waste effluents, which in most cases contain heavy metals. As a general case, in North Egypt, Kafr al-Dawar agriculture soil suffering from a shortage in irrigation water resources. Agriculture drainage water is currently being utilized as a main or supplementary source of irrigation water in this area. The use of such polluted water in soil irrigation raises the risk of contaminating soils with different industrial pollutants such as heavy metals. Therefore, the objective of the present research is to evaluate the effect of industrial activities on heavy metals contamination of irrigation water, soils, and growing plant in Kafr al-Dawar district, Egypt. To evaluate the effect of industrial activities established therein on the environmental contamination with heavy metal, the samples of water, soil, and the plant were collected from sites adjacent to 4 major industrial companies. The location of these companies are indicated in figure 1. So this figure indicates water sampling site at Kafr al-Dawar industrial area. Water sample were collected from 10 sites on the drainage network close to industrial Kafr al-Dawar area. So we have first sample, it was from Mahmoudiyya Canal. This fresh water from Mahmoudiyya Canal. Then we have like 9 samples from agriculture drain network. First one from Kafr al-Dawar drain before receiving the outlet effluent of industrial company. This is the location of the 4 major companies, the Kestel and the Spinning Egyptian company. We have 2 sampling from this company, P and S1, P and S2. Tinting and the chemical company also have like 2 water sampling site, T and the C1 and the T and the C2. Industrial Silk Egyptian company, also 2 sampling site, IS1 and IS2. Al-Beda, these are the last companies, Al-Beda Dyer company, BD1 and the BD2. So this site, if you look, sample number 1 representing the location where the company dispose their liquid waste in industrial secondary drain. It is T and S1, T and C2, IS1 and the BD1. So number 2, this is the point at which agriculture drainage received industrial drainage waste effluent from each company. So I have T and S2, T and C2, IS2, BD2. Also, soil and plant were collected from agriculture soil close to each mentioned industrial company, and they also analyzed it for their content of heavy metals. So all measured heavy metals were compared to the recommendation guideline indicated in the table 1 for irrigation water. This national and international guideline were designed for long-term protection of soil and water resources, plant, animal, and humans. This table shows heavy metal content of the water samples of Mahmoudiyya Canal, fresh water from Mahmoudiyya Canal, and the agriculture Kafr al-Dawar drainage water before receiving the outlet effluent of industrial companies. Then we have this the 4 major companies. Each company has 2 sampling sites. Number 1 indicate the outlet effluent of the company into industrial secondary drain. Number 2 of each company indicate agriculture drainage water after mixing with industrial wastewater effluent of each company. This is the Kestel and the Spinning company. Here is Tinting and the Chemical company, Industrial Silk company, and Al-Beda Dyer company. Figure 2 and also figure 3 shows heavy metal content of water samples expressed as fold above critical limits. This means that all value below 1 indicate no environmental hazard is expected. However, value above 1 indicate heavy metal toxicity are expected. So in figure 2 shows that all measured heavy metal of Mahmoudiyya Canal water which is the main source of irrigation water, are within recommendation limit for water irrigation. However, Kafr Dawar drain water before receiving the wastewater from industrial companies, as we can see, except for cadmium, concentration of all measured heavy metals were lower than the critical limit. So figure 3 indicate, it is the same like figure 2, indicate heavy metal content expressed as fold above critical limit of the outlet effluents of industrial companies, which number 1, T and S1, T and C1, IS1, and BD1, and the Zermaus effluents discharge or mixing point at agriculture drainage water, which will be number 2, T and S2, T and S2, and so on. And this also, we said again, it's a fold above the critical limit. So all value above this dashed red line indicate toxicity, heavy metal toxicity at this site. So let's begin with the first company, the Textile and Spinning Egyptian company. So except for lead and the cobalt, which is less than the safe limit, other measured heavy metals in outlet effluent T and S1 were higher than the safe limit. At the mixing point, agriculture drain was loaded with toxic level of cadmium, zinc, and nickel. Tinting and the chemical company discharge effluent T and C1 with toxic level. نعم.
دكتور مهند تكرمت.
Yes.
تسرع شوي if you can speed up a little bit.
Okay. Of all studied heavy metals over the safe limit. I think this is the highest value of all studied heavy metals at each point. At mixing site, despite the dilution effect of drain water, results showed that all studied heavy metals were above the critical limit. Industrial Silk Egyptian company, the effluent discharge IS1 was loaded with toxic level of all studied heavy metals. At the mixing point, data showed that concentration of heavy metals were reduced to about the half of those in the outlet effluent IS1, but still, except for cobalt, higher than the safe limit for irrigation water standard. The last company, Beta Dyer company, the outlet effluent BD1 was loaded with toxic level of all studied heavy metal. At the mixing point, measurement of heavy metals indicates that the drain water were loaded with less toxic level of heavy metal. However, the value are still higher than the critical limit. So generally, heavy metal content were varied between outlet and the mixing point of companies, but still very high compared to Kafr Dawar drain water. Low stability of reused mixed drain water for long-term land irrigation will have an impact on the agriculture environmental through soil fertility, degradation, and yes.
1 minute, please. 1 minute.
Okay. Soil productivity. This data in table 3 shows the total level of heavy metals in soil next to industrial companies, in addition of the control, which MEC soil, it's soil irrigated with fresh water from Mahmoudiyya Canal. The fold above the soil critical limit for each element at each location was shown at figure 4. Results indicated that cadmium level highly exceed the safe limit, followed by lead, zinc, and nickel. The highest fold above the critical limit for cadmium and zinc were found at the soil adjacent to industrial silk company, whereas the highest fold above the safe limit for lead and nickel were found at tinting and chemical company soil. These high values of heavy metals would affect the growing plants in this area, either in growth or in their element concentration in the different plant organs, which would affect the human and animal food chains. Cadmium, lead, and zinc were the most serious metal pollutant in the soil samples collected from the studied area. It was noticed that the average level of total heavy metals in the soil samples were between 29 to 92 times more than the average level of the same metals of the same heavy metals in the water samples. This suggested that polluted irrigated water can result in increasing the yes, 1 minute only. Okay, level of heavy metals in the soil. So after water and the soil, let's discuss the heavy metal content in some plants grown in the tested polluted. The contents of tested heavy metal in growing plants were reported in figure 5. Data showed that heavy metal content in plant grown in soil adjacent to industrial companies were very high compared to that which irrigated from Mahmoudiyya Canal. The obtained data of soil and the plant shows the positive correlation between the contents of studied heavy metals in both soil and plants. The highest level of all studied heavy metals were observed in plant growing in T and C soil, while the lowest value were observed in the plant grown in Mahmoudiyya Canal soil. Conclusion.
If you can go in 30 seconds on this, please.
Okay. A clear risk associated with irrigation of soil with agriculture drainage water mixed with industrial waste effluents in relation with the heavy metal content. Therefore, it's important to issue laws and limitation for these companies to prevent them from polluting agriculture soils. Industrial establishments should treat their wastes before disposal and dump them under strict measures. Aqueous wastes should not be discharged into irrigation water canal. Finally, newly planned industrial activities should take place away from population masses as well as from agriculture land. And thank you.
Thank you very much, Dr. Ahmad. Thank you, Sayed. Thank you, Dr. Adil. Thank you, dear audience, and I apologize for the technical problem that occurred in this section. I would like to ask all of the speakers, please, to put forward their recommendation to the committee of the conference, and thank you all for attending. Thank you.
Thank you. Thank you very much.
I think it's time for lunch right now.
Thank you for the session. Actually, the